Peak Human.
Les humains à leur meilleur.
C'est tu apogeo.
Peak 人間
Peak Human.
Hey everyone out there in podcast land, I'm Brian Sanders and we're back for another great episode. I had the pleasure of speaking with Dr. Anthony J this week. He's probably best known for his book Estrogeneration, where he explores how all the nasty xenoestrogens creep into our body through plastics, food like soy, personal care products, sunscreen, the water, etc. This is important stuff because you may think it doesn't affect you, but it does, and you just don't realize it. You don't have to go crazy over this stuff, but it's best to minimize your exposure. What was really cool for me is that I got to talk to him before and after the show and realize what a great wealth of knowledge he has on so many subjects, which is also very apparent throughout the episode. We could have talked all day, but we cut ourselves off at 2 solid hours of hot nutrition talk. Dr. J earned his PhD in biochemistry from Boston University School of Medicine, researching fats, hormones, and cholesterol. He's currently at the Mayo Clinic in Rochester, Minnesota, researching stem cells, epigenetics, and infrared light. He also does DNA consulting, which I'm going to do with him in the near future. So now for a huge announcement, the Sapien Show is finally here. I haven't mentioned it much, but it's been in the works for a while. It's recorded on video and audio at Sapien headquarters at Evolve Healthcare in Woodland Hills, California, with in-person guests. My co-host is the one and only Dr. Gary Schliffer, who was a recent Peak Human guest. By far the most positive feedback of any episode. Go back and listen if you'd like. It's episode 48. Or just jump in and start with the Sapien podcast that is launching today. So I'd suggest pausing this episode and subscribing now before you forget. Go ahead, I'll wait. Just look up Sapien in any podcast app or on YouTube. The podcast has higher quality audio, and the YouTube version has our smiling faces. We already have a bunch of great episodes in the bag, including one where Dr. Paul Saladino and Dr. Gary get in a small war. It got a bit awkward after that one. My other co-host is Yaniv Fatucci, the producer of Food Lies and co-founder of Attack Media. He produces shows for Disney, Sony, Nintendo, and all that other Hollywood stuff. He'll be coming in and out and bringing his awesome perspective into the mix. So I'll keep it quick this week on how to support this show, myself, and all things Sapien. My main venture is a Sapien organization, which can be found at sapien.org, which includes the Food Lies film, Nose to Tail grass-finished meat, this podcast, and even the long-term vision of changing the way we farm with the Sapien movement. You can find out more about the Sapien diet there, which people have been asking about. I posted my before and after picture on Instagram, Facebook, and Twitter to show what happens when you eat densely and move intensely and live a Sapien lifestyle. Which is how us modern Homo sapiens in 2019 should be living. I swear it's the easiest thing to do once you understand what to do and why you're doing it. I eat the most delicious meals I can imagine until I'm full. Never worry about calories or macros. Then go work out for 17 minutes most weekdays. And this helped me transform my body and my life. So start eating densely with all the grass-finished meat on nosetotale.org. Support this podcast so I can keep doing it at patreon.com/peakhuman. Pre-order the film so we can finish it. The more funds we have, the sooner it will come out. You can click through to the Indiegogo at foodlies.org. And subscribe to the new Sapien Show on any podcast app and the Food Lies YouTube channel. Without further ado, please welcome the superb Dr. Anthony J. Okay, we're live with Dr. Anthony J. Where are you calling in from? Thank you for coming.
Yeah, thanks for having me. I'm in Rochester, Minnesota, so I'm at the Mayo Clinic.
Awesome. Yeah, that's your day job, right? The Mayo Clinic?
Yeah, it's pretty flexible, though. So that's the good thing about being in research is that I can make my own schedule to some degree. Mm-hmm.
I love it. So yeah, give us a little background. You have a PhD in biochemistry.
Yeah, and then I used to do Alzheimer's research right out of so way back in college. I did some stuff with viruses and research on viruses, and then I did Alzheimer's research after that. And I was actually designing virus, and then I was making virus from DNA, putting it into human cells, and then the cells would make the virus for me. So I would just do the DNA part. I would make the DNA. Cells would make the virus, and then I would spin those out. of the liquid that the cells grow in, and then we would use those to research Alzheimer's, right? Because you can do a lot with viruses. I mean, the idea is to inject them into animal brains and manipulate genes in the brain and things and try and cure Alzheimer's. So use these viruses for good purposes, just at a research level. And then after that, I ended up doing my PhD in, like I say, biochemistry. I did it studying hormones and cholesterol and fats, things like that. So that's where I got off on this estrogen research, because the sex hormones are defined as hormones created from cholesterol, which most people don't realize that, cholesterol is super important for all of your sex hormones. It's like the building block, right?
Well, most people just think, oh, I shouldn't eat that. That's cholesterol. That's what I should avoid.
Right. Yeah, which is hilarious, because it's not only super important, but it's the dietary cholesterol doesn't alter your body's cholesterol in a bad way.
Yeah.
It's a really beneficial thing to be eating, like egg yolks and things like that, I think are super healthy.
Absolutely. I agree. So yeah, you studied all that stuff and then you got into the estrogen side.
Yeah, that was like a huge can of worms that I didn't really realize it was going to be such a big issue, because, I was just worried about the drinking water at first, and then it kind of snowballed into all these other sources of estrogen. And then I kind of realized that they're additive, right? Like if you have one chemical that's acting like estrogen in your body and a perversion, it's not real estrogen, it's a fake estrogen, it's artificial estrogen. But if you have a man-made chemical acting like estrogen, then you throw in another one from a different source, like your sunscreen, and then you throw another one in, like from your fragrance, and then you throw another one in from your drinking water. Those are all acting on the same system. So they're actually exacerbating that system. They're making the estrogen system kind of go extremely haywire instead of just a little bit haywire. And that's kind of, what got me going on my estrogeneration book. And like I said, it snowballed pretty fast, because it came from a place of just me wanting to understand the actual issues myself. And it was worse than I thought. I think most people are in agreement with that once they actually see it, once they study it a little bit.
That's kind of where I'm at, where you don't really understand it, you don't know about it, you don't hear about it. And then you start looking into it more and more, and you're just like, why doesn't everyone know about this? Or, is this a much bigger problem than I thought? And I'm still trying to figure this all out, because a lot of these things don't manifest until much later, which you talk about, right?
Yeah, exactly. And that's a hard thing. It's almost like smoking cigarettes. It's like, it's not quite that bad, but definitely will take decades to have the full effects of these chemical exposures. Cigarettes, they'll kill cells. Like, they do have toxicity, in the classical sense of the word toxicity. Like, they'll straight up kill cells. The unique thing about BPA and phthalates and parabens and some of these artificial estrogen chemicals is they don't straight up kill the cells. So they're not that toxic in a traditional sense.
Yeah.
And that throws a lot of scientists off, because scientists have been trained in a traditional way to think about toxicity as something that kills cells.
Yeah.
And if it's not killing the cells outright, then it must be okay. Right? It's like, oh, it takes 2 quarts of glyphosate. You have to drink 2 quarts before you die. It's like, it's like, or before it's toxic, people will say. In fact, there was a guy, it was quite a while back, but he was a PhD scientist affiliated with Monsanto, the glyphosate production company. And he would say that publicly, that you can safely drink a quart of glyphosate and it's not even close to an issue. And somebody literally on camera, and you can look this up on YouTube, they brought him a quart of glyphosate during that interview. And of course he's like, no. And they're like, well, just take a sip, right? Yeah. And he's like, no.
That's I think I did hear about that or see that. Yeah. That's amazing.
He knows deep down, right? It's like, it's all bullshit. If you're going to pretend like it's just about toxicity and killing cells, it's a little bit of a lie when the guy won't actually drink the stuff after he said he would drink the stuff.
Yeah.
Because when you start to recognize the underlying biochemistry, that's not right.
Yeah. And a lot of these things, it's hard because the stuff we deal with, kind of nutrition and this, it's not super hard science where we know explicit answers. And it's also like these long things that manifest over a whole lifetime.
Right. That's why I called my book Estrogeneration. Most people think of it as like, the title kind of implies we're being feminized. This generation is being estrogenized, if that's even a word. There's definitely a truth to that part of it. I mean, scientists are even using the word male feminization. They're even using that term, because you definitely get feminization, you get shorter penises, you get shorter anogenital distance, you get certain aspects that are feminized.
Man boobs.
Yeah, you get breast tissue development. And in animals, you see it even more dramatically because you can manipulate the doses over their whole lifespan and all this kind of thing. But it's like, you don't need complete sex transformation to have feminization. You know, you don't like lowering testosterone is a form of feminization, right? And that's all going on. Like that's legitimate, you know, research, and that's a legitimate problem. But what's also a bigger problem, to be honest, is the next generation. The exposures that we're having to ourselves are literally they're altering the future generations, even if they're not being exposed to these same chemicals, which is crazy to think about.
That's the hardest thing, because you don't, everyone wants to just think about today or tomorrow. Right. It's like people can barely think about next year, right. Let alone their kids. And this is like epigenetics. Exactly. That's 100% epigenetics. And so that's what I've been focusing on now in my research is epigenetics, because it's the next big thing in science. You know, we understand the genetics, the DNA, the blueprint, but then these epigenetic marks, these marks on top of the DNA, they have a huge role in regulating the DNA. And again, they're passed to future generations, which is mind-blowing, you know, for scientists. Like when Michael Skinner discovered transgenerational inheritance of some of these issues. So Michael Skinner is a PhD scientist out in Washington. He raises between 3,000 and 5,000 mice at any given time. I had lunch with him the other day at the Mayo Clinic. He's a friend of mine. Cool. And he was here giving a talk about this. He specifically has studied a bunch of these estrogen mimicking chemicals that I write about in my book. And of course, he just focuses on the technical aspects. He's written all these technical scientific research papers, and that's his main focus, his career. I try and simplify it for other people as well and try and make it easy to understand. And anyways, he wrote a scientific research paper in like 2005 on this topic when it was first discovered. He basically broke it open. The paper was the most cited scientific research paper for 5 straight years in scientific journals. And of course, the public a lot of medical doctors, professional medical doctors haven't even heard about this stuff, you know? Well, it must have been so unbelievable at the time too, right? Yeah. I mean, and the good news is he didn't quote unquote discover epigenetics, right? Like people were starting to get the idea that it's inheritable, that you can mess up your epigenetics and then pass it on, or you can make them stronger. You can improve your epigenetics and pass that on. But most scientists are more interested in the illness and the sickness and the disease sorts of aspects. But I mean, there's definitely a positive side to this. But I mean, I think it was in the 90s they discovered. So they looked back in history, and there was something called the Dutch Hunger Winter, where the Nazis came into the Netherlands and cut off all the food supply, and they starved for 1 whole year. I mean, just absolute starvation. It was thousands of people. It wasn't like a small town. It wasn't it was just tens of thousands of people. Of course, there was mothers that were pregnant among those thousands of people, and tens of thousands of people, and the babies that were born were much smaller. But that totally makes sense, right? Like the mothers were starving. Yeah, nutrition-wise, it's kind of easy. Yeah, and so that made sense. But then in the 90s, they looked back and they discovered that the children of those children are also smaller, which doesn't make any sense, right? Because they've had all the nutrition, the whole thing. And that was a super interesting finding. It was mind-blowing to people, and the data was super strong. So it's not like you can just kind of say, well, the group wasn't big enough or whatever. And then they started chasing that down, and they realized it's because of, in that case, some of these insulin growth factors and their impact on the epigenetics. So some of these hormones, again, that caused, you know, a whole new field of research, really, with the epigenetics and the inheritance of these health issues or health problems. And it's, you know, it's becoming a bigger and bigger deal, at least in the scientific world. And I'm just trying to make it easy for people to understand, because I think regular people need to recognize the implications of that finding. Yeah, for sure. This brings up a point I read, Deep Nutrition, Kate Shanahan. Yep, exactly. She talks about it. Yeah, she talks about there's not a lot of talk about this, but other people do talk about it, definitely in this space. And it's like, you need to give your genes what they expect. And our modern environment doesn't do that. So yeah, a lot of people are talking about like Mark Sisson, Chris Kresser.
Yeah, it's getting there now, right?
Yeah, but it's so tell us more about this. This
People
stuff,
because
it just seems a little hokey, especially just normal people. Not people listening aren't normal people. I think they're a little more interested in this. But when I talk to just normal people, that when you talk about this ancestral diet and our modern environment and lifestyle, like doesn't, give our genetics what they expect, and that's where the problems come from. They're just like, what? Like, what are you talking about?
Well, and some of it does sound a little bit hokey depending on how you frame it.
Mm-hmm.
But I mean, and some people, even within the health world, I'm not talking about Mark Sisson. He's phenomenal. I've been to his house and I've talked to him.
Mm-hmm.
I mean, he had a great understanding of biochemistry. I was really impressed, actually.
Mm-hmm.
But some people out there for sure don't totally understand it. They're talking about it anyways, and I can tell they don't quite get it. But so that contributes to a little bit of the problem sometimes when people don't fully understand what they're talking about. But I mean, the best analogy is musical notes, and that's the analogy I use in my book, where if you have a melody, right, like Mary Had a Little Lamb or some song, just that's the melody, that's the DNA.
Okay.
Super simple. You pass it to somebody else, you pass that sheet music to somebody else, and they'll play the exact same song. Super easy. There's no mistakes. They can pass that on, etc. Right? But the epigenetics are chords on top of the melody. So like you still have the same melody, you still have the same DNA, but then you add more notes and you make it a symphony. You know what I mean?
Mm-hmm.
And then you can pass that symphony on to somebody else, and they can still play the same melody and the symphony on top. But what's interesting about the epigenetics, you can change it. You can change the chord progressions. You can make it more complex or less complex or whatever. You change the marks on top of the notes, right?
Mm-hmm.
And that, just like when you change the epigenetics, it doesn't change the DNA. The DNA is still what it is, but it does absolutely change the song. You know what I mean?
Or different instruments, or it could sound completely different.
Yeah, and what's really crazy, Michael Skinner is the one that taught me this actually. The most common DNA mutation is a C to T. So this is a little bit technical for a second, but I can't help it because it's so interesting.
Yeah, go for it.
We have 4, when there's computer code, it's zeros and ones, right? DNA code is 4 letters. It's A, T, G, and C. And you have about 3 billion base pairs of those letters to make up your DNA code. So if you're going to get your whole DNA sequenced, you get about 3 billion, code letters in different orders. The most common mutation that you find when there's mutations just between, different species of dogs or cats or bears or different breeds of animals or different classes or whatever, the most common mutation is C to T, the letter C to T. The interesting thing about epigenetics, right? Like one of the forms of epigenetics is called methylation. And then methylation is like one of those physical marks on the DNA. You know what I mean?
Yeah. Chris Masterdon talks a lot about this. I just talked to him yesterday and we didn't get into methylation.
Yeah. Well, he talks about
it's too much. There's too much to talk about with him.
Yeah, right. And he talks more. Yeah, he talks about the methylation pathways and things and how they come about, which gets really complicated with all the B vitamins and all this kind of stuff.
Choline and it's
yeah, exactly.
Crazy.
Just physically, you can get the methylation happens on the letter C, right? You can also make it on the A, but like for the most part, it's on the letter C. So you got A, T, G, and C, and you get methylation on the C. And what that does, that actually increases DNA mutations as well. Does that make sense? So not only do epigenetics change quite frequently, they can actually increase the number of DNA mutations. Like the DNA is supposed to not change, right? Like when you pass on that song, Mary Had a Little Lamb, to somebody else, that melody isn't supposed to change. But if you mess around with the epigenetics enough, you actually increase the rate of change of the actual melody of the song, the DNA.
Not good. Which
is even longer lasting, right? Like that's, who knows how many hundreds of generations you might be affecting if you really screw up the epigenetics.
Yeah.
Which we have no idea about, but we do know that in theory, that's what's happening is you can actually increase the rate of DNA mutation by increasing the rate of epigenetic change, which again is pretty technical. So I'm almost hesitant to even talk about that.
Well, what's going on with that? I've heard stuff like we do stuff with like fruit flies maybe because they can reproduce so quickly and we can see many generations.
Yeah, for sure. I mean, that's where you see things like that. So you can, people definitely have proven that you have these issues in multiple generations. I mean, Michael Skinner, the reason his paper was so blockbuster was he discovered 4 generations were affected in mice and rats. And that's a big deal because scientists, they're kind of skeptical about the epigenetics until Skinner came along, because previously people were looking at 3 generations. But the thing about 3 generations, so what they were doing is they're exposing a mother mouse to BPA, right? And the mother's exposed, and let's say she's pregnant. So technically the baby, the fetus in the womb is exposed, right? That's going to be the baby. And then the fetus has stem cells there, egg and sperm cells, right? And so technically you can see how 3 generations can get exposed all at once.
Yeah.
You see what I mean?
Yeah.
So then you can make an argument that, well, it's not really epigenetics because you're technically exposing all 3 generations in one shot. But Michael Skinner showed 4 generations were affected, you see? And then there's no disputing. It's like, okay, then obviously that's getting passed on. And his experiments were cool, and there's other people that have done this. They just expose the mother, and then they follow out the health impacts, and you see problems with their health 4 generations later, just from that one mother. They don't keep exposing the future generations.
Yeah.
Like, that's the crazy thing, right? Like, you're just exposing one parent, and they've done this with the father as well. So fathers aren't off the hook, like people kind of like to think, well, it's all about the mother and what her health is optimizes the baby's health. But in reality, like the father, the sperm cells have all these epigenetic mutations and methylation changes. Similar problem. You impact the father, you expose the father to BPA, you get 4 generations. I mean, it's huge. It's a long term problem. And that's all they've studied. Like, they haven't gone much further than 4.
Well, so it's super scary, right? Of what's going on today. And we don't have no idea what's going to happen in the future.
Exactly. Yeah. I mean, well, we have an idea because we've done studies in animals.
Yeah.
So like you see fertility decrease, you see breast cancer increase, you see depression increase, you see fat, like you see these animals get fat. Like there was a crazy study with atrazine. So atrazine makes my top 10 list in my book. It's a herbicide, right?
Yeah, definitely want to talk about that.
Yeah, it's the second most used herbicide in North America. And it's totally illegal in Europe, by the way, because it's estrogenic. And that's a kind of an aside issue, right? Like the fact that all these chemicals are illegal in Europe and they're all over the place in the US.
Should tell us something, but yeah.
Yeah, exactly. And so just as really stepping aside for a second, Michael Skinner, since I brought him up, he gave a talk in Europe about a fungicide chemical that was acting on the epigenetics and messing up health of all his animals. And he gave a talk in Europe about that fungicide. It's a spray they use to kill fungus on grains and things. And they outlawed it within 2 weeks after he gave his talk in Europe.
Whoa.
They outlawed it. Yeah, 2 weeks. And in America, that talk he gave was like 5 years ago. We're still using that same chemical today in America.
Whoa.
Yeah, so the
Okay.
rate of change within our political system is absurd. The fact that we're allowing these chemicals to be legal before we're testing them fully is kind of the root cause of that issue. And then the fact that the politicians are pretty much bought off with all the funding and all this, that situation is just exacerbating it. But anyway, so going back to what we were talking about before, this atrazine, right? I wanted to tell you about this study. So there was a researcher who exposed a big group of rats. So they had 2 groups of rats, exactly the same food, exactly the same calorie number. They gave all the rats the same calories, same food, same water, everything exactly the same. The only difference was one of the groups, they gave low dose atrazine. And this is not toxic. This is not killing the rats, right? It's not killing sperm cells. It's not killing anything in the rats. It's non-toxic dose, low dose, just like a lot of people are getting. What did they find? They found the group with the low dose atrazine, again, same calories, they got fat. And they had other health problems too, like all this insulin resistance and all this other stuff. But, that's the kind of thing that we're starting to see. So we do have ideas of where these chemicals are taking us. And a lot of it is based on the way our body works with natural estrogen, right? Because when a woman's estrogen goes way up, when a woman gets pregnant, for example, you get breast tissue development, right? Like that's a natural process. You get fat gains, you get fat storage because fat is an extremely efficient storage form for energy. And if there's a famine or something, which our ancestors absolutely had, that woman needs to have plenty of energy to provide for the fetus. You see postpartum depression, right? When that estrogen tanks out after the woman has a baby, oftentimes you get certain forms of depression. If that system gets out of whack, sometimes you get blood clots or you get these varicose veins and things like that. When estrogen gets a little bit out of whack, right? Like it's ironic that all these issues are reflected in the artificial estrogens, in a perversion, right?
Yeah.
Like I said, low testosterone. You definitely see fertility issues. So we have a pretty good idea of where we're going, like what direction we're taking with these chemicals.
How does that work exactly? You kind of explained it before and now, but just how did these like fake estrogens work? What are the pathways? How does that? How does that
well,
make
so
us
many
fat?
different. There's so many different pathways, like atrazine. I mean, most of them bind the PPAR gamma, if you've heard of that.
Mm-hmm.
PPAR and then the letter gamma, the Greek letter. And in my book, I talk about that being like the fat switch. It's kind of like a light switch. You flip it on and then tells your body, hey, start storing fat. It's like a master regulator for fat storage. The estrogen specifically interacts with that. In terms of the testosterone declining and things like that, there's definitely some interplay and interchange between testosterone and estrogen. Mm-hmm. So if you bring up your estrogen super high, your testosterone tends to lower.
Yeah. Or
the effect of your testosterone lowers. And that's partially through something called SHBG, sex hormone binding globulin. So in other words, like even women that take birth control, their SHBG goes up. Their sex hormone binding globulin goes up because their body perceives that they have more estrogen. So even if your testosterone doesn't drop, even if the testosterone stays the same, there's more SHBG, so there's less free testosterone. Does that make sense?
Yeah.
I mean, I explained it more simply in my book, so I'm getting a little technical here. But in my book, I say like basically SHBG, I call it the limo for sex hormones. Mm-hmm. Like they have to get in the limo and drive around your blood, right? Because they float on water, just like cholesterol. Like if you put butter in water, it floats. So your blood is like water, so you can't put testosterone in your blood. It'll float. You know what I mean? It can't get around your body. So it has to get into the limo and cruise around your body, and then it can't stay in the limo. If it stays in the limo, it's stuck in the limo. It's not doing anything. So you got to get it out. And these estrogens, they don't let it get out. They put a whole bunch more limo into your blood, and then all the hormones are sitting in the limo and they're not getting out and actually acting on your body. Mm-hmm. So they lower your free testosterone, right? Mm-hmm. And your free estrogen, actually, your free natural estrogen. And then they also do something unusual. There's studies that show they block the androgen receptor. They block the testosterone receptor. And that's the analogy I use for that is hockey, right? Like because I played hockey. Yeah. If you put a piece of plywood in front of the goal, it doesn't matter how many shots on net you have, right? If you're blocking the goal, you're not going to score any points, right? Like you could have 50 players on the ice, like 50 against 5, It doesn't matter. If you got a piece of plywood completely covering the goal, you're not scoring. You're not going to win the game. You're not going to get any effect. And the testosterone is the same thing. If you're blocking the testosterone receptor with these estrogen chemicals, which some of them do, you're not going to have any estrogen effects. You know what I mean?
Or you're going to block it. Even if you could take exogenous testosterone, but if it's blocked, it still can't even get in.
Exactly. Yeah. So that's obviously a problem. You have to compete with these xenoestrogens. And the specific study was done with something called 4-methylbenzaldehyde camphor, which is a sunscreen chemical. And that one's, of course, illegal in Europe, but it's all over the place in America. And most people don't look for it on the label because it's such a long term. It's 4-methylbenzaldehyde camphor. Who knows how to spell that? Like people do watch out for oxybenzone. And that one's a bad one. That's also called benzophenone. Mm-hmm. It's one of the benzophenone chemicals. And they just outlawed sunscreen in Hawaii specifically because of that chemical. I don't know if you've heard about this.
Yeah, I did. Well, I'm from Hawaii. I was born and raised. Cool. And I mean, isn't it like killing reef in Australia as well?
Yeah, they've pledged in Australia, New Zealand, Philippines, all these places. They've also pledged to make it illegal. Some of them haven't implemented it yet. It's like by 2020 or 2021 or whatever. Yeah. But there's a whole long list of countries now, even in the Caribbean and things, they're doing this. And it's partly because of my book, actually, because everybody was denying it before then, and now people are finally saying, okay, fine. It's pretty obvious that it's definitely affecting all manner of animal species, including the reefs, including fish. And I mean, they're finding some of these estrogen chemicals they're finding in polar bears in northern Alaska. They studied 11 polar bears and they found every single one of them had parabens in their fat. because it's in the water and it's going up the food chain.
Is that from the plastics as well in the water?
For sure, yeah. But that parabens specifically are from the fragrances. They don't use parabens in plastics.
Mm-hmm.
For sure, there's a ton of plastic chemicals in the water supply, which is a huge problem. I mean, that's one of the reasons I'm not a fan of sea salt anymore.
Yeah.
I always prefer to get it from like an ancient seabed, like Utah, or like the Redmond's.
I'm kind of on board with the whole Redmond's.
Yeah,
thing.
the craze.
It's a craze, especially in our like kind of like ancestral health. It's like the craze. But I mean, it's from a mine and it's like pretty well protected.
Exactly. It was before there was pollution, right? I mean, pretty much a prehistoric ocean, deposit. And similar with Himalaya, right? Like you get in the Himalayan sea salts. I mean, there's obviously no plastics from those, ancient deposits.
Yeah.
And there's iodine in there. That's why it's pink and things like that. And most people are deficient in iodine to some degree or other. So anyways, like the oceans are filled with these microplastics. And just like 2 weeks ago, I was in Colorado giving a talk for the special operations, the military, and on this issue, actually, and some of the DNA consulting that I do. And then literally while I was there, they came out with some news articles about they're finding plastics in the pristine mountain lakes, like up in the middle of nowhere, because it's coming down in the rain.
Wow.
So it's getting up into the air somehow. It's coming down in these mountains in the middle of nowhere. They kind of accidentally came across these plastic particles. And I'm not saying that's like a toxic dose or anything like that, or even changing the fish species. But in the middle of nowhere in Switzerland, I write about this one in my book. They have a lake. I mean, a pristine mountain lake in the middle of nowhere in Switzerland. And they discovered the male fish were becoming feminized. So they called it gonadal malformations or something. They used some kind of technical term, but basically it was male fish were becoming female.
Isn't some of the frogs were being feminized?
Oh, yeah, for sure. Yeah. I'll tell you about that in a second. But first,
okay.
The mountains, they discovered the male fish were becoming female. Again, they called it gonadal, whatever.
Yeah.
They used some hidden term to make it more political. And then they discovered there was a river that went into that lake, and it was like a massive distance away. It was coming from this city, and there was a bunch of birth control in that river. And then they tested the birth control in the fish, and they all had the birth control and stuff. So they're getting estrogenized from that river, from in the middle of nowhere. There's been cases, like there's precedent for these issues in these really remote areas sometimes. It doesn't happen all the time, and I don't think the rainwater is going to cause that much of an effect, but it's just illustrating how pervasive these plastic chemicals are becoming.
Yeah.
And how tiny they are. These microplastics are able to evaporate up into the water. But the gay fish with Alex Jones and everything, or the frogs, I guess, the gay frogs, right, with Alex Jones, especially. I mentioned that in my book a little bit because the thing about frogs is they sit in the water, right? So their skin absorbs these chemicals, so they're more sensitive to it. And I'll just give you the numbers, right? So men, our natural estrogen is about 20 nanograms per liter. Okay. Some people use the 20 picograms per milliliter, but you can also say 20 nanograms per liter.
All right.
So whatever, the units, 20 nanograms per liter. Women, actually, ironically enough, are also about 20 nanograms per liter, up to about 400, depending on the time of the month.
Okay.
Or maybe up to 200, 20 to 200, something like that. So it's not that different, right? Like most guys, if you were to ask them what estrogen, so you'd say men are 20, where are the women? They'd say thousands, right?
Yeah.
It's not really true. It's not that much different. And nanograms, by the way, is a tiny, tiny amount, per liter. That's 10 to the minus 9th grams, 0.0000001 gram.
Yeah.
So anyways, that's where our natural estrogen is. Now, the legal allowable level for atrazine in the drinking water is 3,000 nanograms per liter, right? So we're and oftentimes they find it way above that level. And again, it's based on toxicity. It's like, well, where did the cells die? You know what I mean?
Yeah.
Oh, it takes a good 3,000-4,000 before you start killing, or maybe it takes 10,000. So let's be conservative and drop it down to 3,000 nanograms per liter, right? Now, again, I argue that that's a problem because you're going to get all these estrogen effects at those levels, right?
Yeah.
And you do, like, absolutely give them a low dose. The rats get fat, right? But the crazy thing is if you put frogs in water that's 200 nanograms per liter of atrazine, the male frogs become female, and they literally start mating with each other and things like that. Like it's that extreme.
And that's at 200. And then
That's
you're
at
talking about
200.
3,000 is illegal.
Exactly. Yeah, you got it. I mean, you can see the obvious, right? The regulatory, how basically the EPA, the FDA, and all these regulatory boards have completely dropped the ball on this. Yeah. Just because the scientists are saying it's okay, it's not toxic.
And they're not like bought off or anything. They're just doing their work and they just don't understand all this.
I don't know. I don't know. I mean, honestly, I don't know, but maybe, right? It's hard to say. I mean, it could be completely. It's weird to me when you get these Instagram pages or these people that are super defensive and they say it, you know, like you can drink atrazine or you can drink glyphosate and all this stuff and it's okay. Like, it's weird to me. There's definitely, I like follow some of these Twitter feeds and some of these Instagram pages just to see what they're saying. And I don't comment on them. I just kind of get a sense of, you know, like how they're they're basically saying organic food doesn't matter. It's totally a joke and all this stuff. And then a lot of them have PhD credentials and they're scientists and this and that. In fact, I think there's more professional scientists that are of that mindset than there are of the ones in my mindset, and probably more your mindset, which is that we need to err on the side of caution if we don't know, number one. And if we do know, it's not really about the toxicity. It's about some of these longer term effects, and our ancestors weren't exposed to it. So it's probably not good, even if we don't completely understand the full picture yet. You know, that sort of thing should be the framing, but most scientists aren't framing it like that.
That should kind of be the default. But I think part of the problem is these scientists, it's good though. They're trying to be science-based. Like, I've talked to some of these people. They're like, I do evidence-based medicine. I do this. Exactly. Right. Yep, so then that's their default mode, but it's kind of to the detriment because we can't always have the hard science, or we don't know how it's being done or what other factors or all that stuff.
Exactly. And there is a culture within science, right? There's a certain groupthink without a question that if you talk about vaccines and you're negative about vaccines, you get ostracized like crazy. Like, it doesn't matter if you have good scientific evidence or not. So there is a little bit of a religious dogmatism in science. And it's like, if you don't follow our religious doctrines, you are you're the problem, you're right? Like, it's not it's not completely evidence based from that perspective. Testosterone is similar. It's like people that take testosterone and they optimize testosterone, there's a culture within science that says that that's an awful thing to do to your body, even though the evidence isn't there at all. It's probably the opposite. Like, for a lot of men, especially with all the estrogen exposures that we've had over the years, and we have all this testosterone resistance, just like insulin resistance. Now we've got testosterone resistance, and a lot of men need to get on the testosterone to really optimize themselves these days. Like
replacement therapy, you're talking about, exactly. Like at a certain age. What age?
I don't even know. Like, to be honest, the age, you know, you see 20-year-olds now that are, you know, like most people are saying, oh, you've got the testosterone of an 80-year-old or whatever. But nowadays, that's not really true. They've done a giant study just looking at age differences, and there's not much difference in total testosterone with age. It doesn't really decline the way everybody says it does.
Well, it shouldn't. Like our ancestors, it probably didn't, right? It's like
Exactly, yeah, and it doesn't. But the free does. The free testosterone does decline with age, so that's a problem. So but your total numbers don't really decline that much. Again, you have to look at giant studies. People, when they say like testosterone declines as you age, total testosterone, they're citing really old studies from like the 70s and 80s and things. But now they've done massive scale studies with hundreds of thousands of people. And you can find outliers. You can find people that are super far outside of the mean and the norm, the standard deviations and things. But outside of that, it's really stable, like our testosterone, but it's low across the freaking board. You know what I mean?
Yeah,
like,
so
it's
something's
low
going
in age
on.
20.
Like, we know something's going on, and then the question is just, what are the biggest factors, or how can we fix it, and all that stuff, right? Yeah,
exactly. And I don't think estrogen is the only factor by any stretch, but I do think it is a big one, and it's fundamental. It's like, you got to at least get rid of these artificial estrogens, because we absolutely know they'll drop your total, they'll drop your free, they'll block your testosterone receptor. Just those three things all acting in a negative way on your testosterone is not something you want to have. And we know about those three things. So let's at least start there, in my mind.
Yeah. Guys, I should be focused on this. Number one thing,
Right.
Well, not number one thing, but just guys should be focused. How do I
Fundamentals.
not have my estrogen go up and keep my testosterone? So let's list all these things. We've mentioned a lot of them, but maybe you could give us your power rankings.
Yeah, it's tricky to rank them because, some of these aren't that well studied. I have artificial red dye on my top 10 list.
Mm-hmm.
So that's one of them, like the man-made artificial red dye. So in Europe, it's not illegal to have red food coloring, but you have to put a warning label on your food if you use it. So nobody uses it. I've talked to people over there. Even in the UK, nobody uses it. They use beet juice to dye their red velvet cake or their Powerade or whatever the hell.
It seems so harmless, just a red dye.
I know. Well, it's funny because they did a poll with all these experts in the field of artificial red dyes, right? These people that really study these artificial red food colorings, and this was like a political thing. They put together a committee, and they were asking experts basically where they stand on, allowing these artificial red dyes to be legal. And 93% of the scientists on that committee said, we need more studies. We don't have enough studies. There's almost no studies on it. We haven't even looked into it. The interesting thing is if you do research with cells in a dish, if you know a scientist, you can ask them about this. We grow our cells in artificial red dye. Like the liquid we put on our cells, which imitates blood, they add artificial red dye to it because as the cells utilize and use up the nutrients in the dish, the liquid becomes acidic and the red dye turns yellow. It's like a color indicator for when you need to change the liquid.
Okay.
So it's kind of a lazy way to change, I see it's turning yellow, so let's change it.
Yeah.
Let's give the cells some new liquid to grow on, right? They've depleted all the nutrients. Problem is that dye is estrogen. And scientists know this because if you want to do an estrogen study, you pull out that red food coloring. You take that out because it'll screw up your cell. It'll screw up your results.
Your data, yeah.
And one of the problems, because so many thousands of scientists are doing studies in cells that are growing in estrogen, they're growing in this red dye liquid, it's screwing up all those studies from that perspective. You know what I mean? So then they're adding more estrogen, like birth control or like whatever the other ones we'll talk about in a minute, atrazine. And then the cells are fine. It's like, well, you've already killed off all the ones that were sensitive to estrogen, and you're selecting out the ones that can withstand the estrogen because you're growing them in estrogen.
Yeah.
And it's like illegal in Japan and all these other places. Like the red dye, but that's a huge example of one that's barely studied. It's hard to rank it and say like, well, this one is more estrogen than that one because
we don't need
nobody's studying it. No, I know what you mean. I know. I'm just saying like that's a question I get all the time. People always are telling me,
they want to know
give me the number one, the number two, give it in order, right? That's well, I can't because the research hasn't been done there. You have an expert who's just an expert in birth control. Like that's all he studies, right? Toxicity of birth control. And then you've got a guy over here in a different state at a different university who's just an expert in atrazine. And that's all he studies, right? And to be honest, that's not even true. Like nobody just studies atrazine anymore because there's no money in that. You just do a quick side experiment here or there just on atrazine. But there's literally nobody who's looking at all the estrogens in combination, which is a problem. So it's even harder. But anyways, so red dye, that's one of them. So stop drinking those juices that are artificially dyed with red food coloring, especially the athletes. It's a complete joke, when you see the pro athletes endorsed by these companies.
Powerade or Gator. Yeah, it's like that's...
And they're drinking, and almost always are red,
That's crazy. Well, quickly, it's great that I hope most people listening, because this is all I talk about, is they're not eating these types of foods anyway, right? They're not eating the processed foods, the sugary foods. So this is good. Yeah,
that's a good start. Yeah, and it's everywhere. Like they did a study, just a purely observational study in grocery stores, and I think 70% of the total food items in the grocery store, 73% or something had artificial red dye in them. So it's a huge majority of the foods have red dye, not red, but some color, some fake artificial red dye, and 40% of those had the red one. So the red is by far the most common if you factor in all the different colors, which is crazy because that's probably one of the potentially the worst one. It's the worst one for generational health, right? Because these estrogens impact multi-generations. They're not that toxic, but they impact multiple generations. So anyways, atrazine I mentioned before. Atrazine, second most used herbicide. There's more and more data now coming out on glyphosate as well, showing that it's acting like estrogen. So herbicides in general. particularly with soy. Like if you have glyphosate in combination with soy, it's even more estrogenic. There's no question. I mean, if you looked on PubMed at glyphosate, soy, estrogen, you'll find studies about how they're additive, they act together, all this sort of thing.
And glyphosate has its own problems beyond estrogen.
Exactly.
But then also with soy, I'm guessing you're going to talk about how bad soy
exactly.
is.
For sure. Well, yeah, that's the natural progression, right? Like, I mean, they did a study with over 100 food items, just plants, like broccoli and cauliflower and whatever, over 100 of these plant food items. And literally all the plants were under 1,000 units of estrogen, except soy and flax. So all the plants under 1,000, most of them were under 100, but we'll just say 1,000. Soy was over 100,000 and flax was over 300,000 units of estrogen.
Wow. Yeah, and these are
like not even in the same, right? It's not even in the same country. Like,
it's orders and magnitude.
Exactly.
And these are regarded as health foods. Exactly.
Yeah, and that's the crazy thing, right? There's really not a lot of redeeming qualities about soy. Unless you're post-menopause or something and maybe you want to increase your estrogen. I mean, there's an argument to be made there. That's okay. Yeah. But I don't think that's the best way to increase it. Like, I think licorice root or something, if you're going to act on your estrogen receptor, there's good reasons to use licorice root instead of soy.
As a female.
If you're post-menopause, right? Yeah, if you're in that specific situation, right? Yeah. And for a man, it's like, boy, the thing about flax, even though it is crazy, crazy high in estrogen, it's got omega-3 fatty acids. So it's like, well, people do need those, you know? So, but it's like, well, you don't need them from the flax. And then what's also interesting about flax they're coming out and finding now is that it has CBD. So there are some anti-inflammatory, there are some beneficial aspects that some people, you know, find. And sometimes they think that outweighs the estrogen aspects of it, but it's like, well, guess where else you can get CBD?
Yeah, exactly.
You can get a lot more CBD for a lot cheaper from hemp because there's not that much in flax. You know, it's not like if you're going to try and purify it, you're going to use the hemp plant. There's way more in there.
Yeah.
So, like I said, the flax and the soy, it's just not even the same.
So it's a problem with, especially with vegans, because they're trying to get the omega-3 somewhere, and but it's like, if you're eating a normal species appropriate diet, you can get omega-3s from a lot better sources.
Exactly. Yeah. Especially fish, obviously. But nowadays, you know, most people aren't eating that much fish. Depending on your genetics, right? Like I would supplement it, but it does depend a lot on your genetics. Like if you've got that ApoE gene that gives you a high risk for Alzheimer's, you definitely should supplement DHA or krill oil or something like that.
And are those as good? I definitely want to talk about this because for one, my mom is stage 7 Alzheimer's, and I'm about to get DNA tested. We got to talk about DNA testing soon at the end of the show. But I'm definitely trying to eat more fish oil and fish and all that.
Right.
But so for one, is that as good to get? Like there's like cod liver oil.
Well, it depends, right? Yeah. Well, first of all, some people get Alzheimer's because of heavy metals, right? They've got a gene issue on the transferrin gene, the TF, it's called letter T, letter F, transferrin, and their brain doesn't clear heavy metals very well, and that gives them Alzheimer's.
Don't eat tuna.
Well, if you have that gene, right?
Yeah.
And that's completely independent of DHA, fish oil, krill oil, anything. It's like if you got that gene, I would have a different recommendation, right? But if you've got the ApoE gene, then it is all about DHA. But there's another gene called cholesterol ester transfer protein, CETP. That one gives you a big risk for Alzheimer's, and it's related to triglycerides. Like if your triglycerides are really high, then you got the risk. And there's another one with inflammation-related risk, right? Like completely independent of DHA. And then there's a bunch of categories for Alzheimer's in my mind. It's not just one thing.
I had Bredesen on and talked about all the different.
Interesting.
Yeah.
He wrote a book, right?
Yeah, The End of Alzheimer's.
Yeah.
But he had like 5 different categories, and some of it was like toxin, some of it was more, insulin related, like insulin resistance of the brain type thing.
Yeah, exactly. I mean, that's what I'm thinking. That's the way I think about it too. Yeah. I've been thinking the exact same thing, and I'm gonna have to check out his book. I've heard a bunch of people talk about that.
Yeah, definitely. I still haven't finished it, but you can check out my podcast with him too to get an overview.
Good idea. I'm going to, because I've been thinking about the same sort of thing. In fact, I've even thinking about writing a book on that exact thing. Yeah. But from a genetic perspective instead of from, just here's what I think perspective, because the genes make it more precise. It's like, well, how do you know, right? Like, how do you know which class you fit in? Well, it's easy. You do the 23andMe test.
Yeah.
I don't know if he mentions that. Like I say, I have to read his book because that's where I'm coming from. But in terms just of the DHA, there's no question that the phospholipid form or the triglyceride form of DHA get into your brain better. So like, which is not fish oil. Like fish oil, most fish oil does not have much phospholipid or triglyceride. So triglyceride means 3, right? Tri. So that means there's 3 fat DHAs linked together. Whereas most fish oil is just single. Like if you hold up one finger and you point, that's a single DHA. If you hold up 3 fingers, that's 3 of them linked together. That's triglyceride. When you have 3 linked together like that, it gets into your brain a lot better, which obviously is what you want when you've got Alzheimer's risk.
So that's if you're eating
things
the
like
fish
krill
oil. You get those.
Yeah, exactly.
Or what about like
fish
salmon
oil,
roe?
krill. Exactly.
Eggs,
salmon roe, eating whole fish, krill oil, and there's some species of fish, I think one of them is menhaden from New England, that have a lot of the phospholipid or triglyceride. So you can find supplements, but you kind of have to look for it. You have to know what you're looking for. But you have to be specific about it, I think. But again, you don't have to spend all that money if you don't have that gene. You can save like hundreds of dollars a year if you don't have that gene, and you don't need to take any of that.
Yeah.
So it can actually save you money to do the DNA consulting, which I tell people.
Yeah. You do it.
But of course, I'm biased, right?
Yeah. But you read it. So it's like, because it is a few $100s to even get the test in the first place. So it's like, but then.
Well, it's like if you do it with Ancestry, it's like $60.
Oh.
And Ancestry is better than 23andMe.
I'm sold.
Ancestry. Exactly. So 23andMe, they used to use a company called Illumina they would outsource the sequencing. They would send the spit sample. You spit in a tube, right? Then they would send it over to Illumina, and Illumina would sequence 900,000 SNPs, right? Which is obviously a ton of data. And then they give you the raw data, and guys like me can analyze it, right? Like that's what I do for a living, basically. I can use that raw data, the code, and tell you what's going on with your diet, with your brain, with your detox, with your sleep, with your training protocols. Like I do all those categories. So, but the thing about 23andMe, they used to do that. So 900,000 SNPs, but then they decided to make their own sequencing machine. And now it's only about 600,000 SNPs, which is still a lot, right? Like I'm not going to, I'm not going to scoff at that. It's a lot, but it's not 900. And Ancestry, they still outsourced to Illumina, and they still do the 900,000. So in other words, Ancestry is better and it's cheaper, which is crazy, right? Like it's like, unless you're interested in something else that 23andMe has, they have these health reports that they give you for $100, but they're kind of a joke. Like people that use them always complain about how they didn't get anything beneficial from them in terms of information about their actual health. So, even from that perspective, 23andMe is not really good.
Okay. I'm going to do this right after. So I definitely want to get a consultation from you. So I've heard you talk about it on another podcast, and I'll get this. We'll kind of
do it on the air if you really want, depending on how confidential you want it to be.
Maybe.
Yeah. With my family, like my brothers and stuff, I've done it for my kids. I've done it for I do it for my brothers, of course, way back, a long time ago. There's so many opportunities when you're doing it for family members for like humor, because it's kind of vulnerable, right? It's like, what are you going to tell me? People get nervous, right? Yeah. But for the most part, it's all about prevention, right? Like it's all like, okay, I've got this Alzheimer's risk. Is that scary? Like if you've got the ApoE44, the bad version of that ApoE gene, you have a 70% chance of getting Alzheimer's. Yeah. So that scares people. But the thing about it, you can also completely prevent it, most likely by just doing DHA supplements every day. But man, that's expensive if you don't need to.
And also 95% of people in America probably have a bad diet and lifestyle, in my opinion. Right? So it's like, I believe that I can definitely prevent it.
Exactly.
I know what to do.
And that's true of all the studies, right? It's like, well, you have a 3-fold increased risk for prostate cancer. It's like, all those people that they did in the study, they're standard Americans, right?
Exactly.
But at least if you understand the biochemistry, like if that prostate cancer is related to carb intake, like sugar, if it's an insulin receptor, like the insulin receptor 6 or something, it's like, well, then let's be careful with carbs. Like, let's do intermittent fasting. You know what I mean? Like, let's be real specific about that.
So part of my story why I'm making the film is that my parents ran into health issues, and it kind of came to a head about 5 years ago. And my dad actually died of prostate cancer. And my mom is like unresponsive, like the very last stage of Alzheimer's. So yeah, this stuff is really important to me.
Yeah. And like I said before, like prostate cancer, it can be related to estrogen without a doubt. The thing that's unique about estrogen, testosterone, when you have testosterone in your body, there's one receptor. It's called the androgen receptor, right? So I like to joke, like men are simpler, testosterone is simpler. Whereas women, it's more complicated. Like with estrogen, there's two receptors. There's the alpha, estrogen receptor alpha, and there's estrogen receptor beta. And not only that, there's three different estrogens. There's estrone, there's estriol, and there's estradiol. And they all have different effects on the different estrogen receptors. So you see how complicated that suddenly got?
Yeah.
Instead of like, oh, you got testosterone, and then you've got the testosterone receptor, the androgen. Now there's three different types of estrogen. There's two receptors.
Permutations of it all.
Yeah, and then they say like the estrogen receptor is promiscuous, meaning it like binds a lot of other stuff. Which is also kind of a funny term, but it's a technical term. Scientists use it. That makes it complicated because it's more willing to bind all kinds of stuff. Whereas testosterone receptor, like, oh, let's take a bunch of plastic like BPA and it'll increase our estrogen. You don't have the equivalent of that with estrogen or testosterone. Whereas you can mess with your estrogen. It's harder to mess with your testosterone from that perspective. Like there's no artificial testosterone, that people would think. There's actually a couple, but I don't want to get into it. It's complicated. But the estrogens, because there's two receptors, so most of the breast cancer and the prostate cancer risk is related to the estrogen receptor alpha activation. Whereas most of the prevention of breast cancer and the prevention of prostate cancer from estrogen is related to the beta receptor activation. Does that make sense? So in other words, like if certain people have a risk for prostate cancer based on their estrogen receptor alpha genes. And in that case, you want to take some kind of estrogen receptor beta activator like licorice root. That's why I mentioned licorice before, because it actually increases your beta activation, which decreases your alpha activation. So it's protective against prostate cancer. But again, that's kind of a specific thing based on your genetics. It's not something I would do just willy-nilly, you know. But that can be, just like Alzheimer's, like prostate cancer is not a single thing. There's a bunch of different ways you can have prostate cancer.
Yeah. I need to do this. This is kind of one of those things. I think a lot of people struggle with either being scared of like the results to get a DNA test, or they're just busy or this and that. And I make the same excuses myself, being busy and scared. And then I'm doing it. It's
use an alias, just call yourself Superman or whatever when you send in the DNA.
I mean, some people are scared of that too, I guess. They don't want their data
That's what
I
hear a lot, right? I hear that a lot. But it's like, it's not really that, like, there's public databases with thousands of people's full DNA sequences on them. And they can't even the Chinese can't even figure out what to do with those. It's like, why would they be hacking into your personalized DNA, which isn't even the full sequence? And like, what would they do with that? What do they need? Like, I can't even imagine what you could possibly want with that. But in the meantime, even though I can't, I still recommend people use an alias. Like, what the heck, throw an alias on there. 23andMe doesn't need to know. Our Ancestry doesn't need to know your name.
Yeah, well, let's do it.
They can use your credit card, but if you buy a couple kits.
Well, it's also you're going to get so much more benefit from knowing than not knowing.
Right. That's what I think too. Yeah.
So what else do you look for? How does it work? You wrote your own software, with help from someone else. But yes, you have.
Yeah. I hired somebody to write the code for me because I don't know how to do that, but I told them exactly what I want. Said, here's what I need. Here's what I want. Here's what I want it to look like. Here's all the thousands of genes that I want. Yeah. So I just put it into my software and it gives me the readout of which genes are problematic. So of course, everybody has thousands of good genes, right? But I'm not interested in your good genes. I'm interested in the bad genes and how to fix them. And most people don't realize we have 2 copies of DNA in every cell in our body, except egg and sperm cells. So egg and sperm cells only have 1 copy of DNA. And then of course, when they fuse together, that's where you got the copy of DNA from your mother and the copy from your father. And so that's also, like, scientists use the terms plus, minus, minus, minus. So if you have a plus gene, that usually means you have a bad version of that gene from your mother and a bad version of that gene from your father. Okay. Like a plus minus means you got a bad version of that gene from one parent and a good version of that gene from the other parent. So it's less of an impact, right? plus minus. But then, of course, if you have a minus gene, that means you got two good versions from both parents. And we don't even need to think about the minus genes you have because they're functioning fine. It's like, well, let's figure out the bad ones. And how bad are they, right? Are they plus? Are they plus minus? Sometimes there's genes where even if you just have one copy of a gene, if you just have a plus minus, it still causes a pretty bad health problem. But then in other cases, if you got like a lot of the time, if you have one bad copy of a gene and one good copy of a gene, your cells can detect the bad copy and shut it off, and they'll just use the good copy.
Okay. So
sometimes you have to have a plus to actually have the impact of the gene, like the problem. So what I look for is, of course, like the genes that are pretty well studied and what the specific impact is, and then trying to understand the mechanism of what's going on. Like I said, with the prostate cancer example, right? Like if you've got that prostate cancer risk and it's related to estrogen, even though they've never, maybe they have, but they've probably never done a study on people that have that exact gene, and they've given them a healthy diet and lifestyle, and they've given them licorice root, right, to fix that estrogen receptor issue. Even though they've never done that specific study, it's probably going to be a good thing. You know what I mean? Like, so that would be my suggestion. It's like, well, take licorice root, you got this gene, or avoid carbs. Like, be really careful with carbs if you got that gene, right? That gives you a higher risk of prostate cancer from carbs, right? Or whatever. And there's so many different. Like another example that I'd like to talk about that's really specific is your retinol. Like a lot of people, they have a gene issue where they have a 30%, like a plus minus gene, a bad from one parent, a good from the other parent, that gives them a 30% reduced conversion of beta carotene to retinol. Yeah. So beta carotene, that's from carrots, right? That's where it was named.
Yeah.
It's orange. Like carrots are orange because of all the beta carotene, but your body doesn't have beta carotene. You don't have carotene in your body. It doesn't use beta carotene. What you use is retinol. So if you eat carrots, it's not actually good for your eyesight, like everybody tells you.
It needs to convert.
It has to convert to retinol. Exactly.
Yeah, well, this is something I talked about with Chris Masteron a little bit, and just in general, is that, also just because I talked to a lot of vegans online who are crazy.
Yeah.
But I'm just like, hey.
It's a good example of that.
Yep. Yeah, it's like these vitamins from plant sources don't convert in your body.
Right. Well, and there's some people, like I say, they have a 35% reduced conversion. So for them, eating retinol or liver, which is pretty much the only source of a lot of retinol, is pretty much, and animal foods are the only source of retinol. Plants don't make retinol. You can't get it from them. You got to get it from, animals, and liver is the best source. So then if you got that gene issue, you want to make sure to have liver, right? And that's a pretty common gene issue. But even more so if you've got the plus, which gives you a 70% reduced conversion of beta carotene to retinol. So you almost don't convert any of it. Then you really need to make sure you get liver, right?
Yeah.
Whereas if you don't have that gene, it's like, who cares? You don't have to go running out and getting liver and eating liver all the time.
Well, liver's good in general. It's good to have all the vitamin A.
Yeah. Well, what's interesting is some people have high iron risk, right? They have hemochromatosis genes.
Yeah.
Then they have to be careful with liver. So there's just from a dietary perspective, especially if you've got the heavy metal genes where you've got a risk for Alzheimer's based on clearing heavy metals and iron. Iron is included in that. Like if you got too much iron in your brain, it can increase your risk for Alzheimer's from that transferrin gene. So that's the worst combo, is if you've got like a hemochromatosis gene, where meaning your body stores a lot of extra iron, and you've got the transferrin gene, meaning your brain doesn't get rid of iron or heavy metals. Then you got a big risk from Alzheimer's, right? That would be a rare combination, but I see it all the time. Like I do see it. It's not like unheard of.
So you wouldn't be eating a lot of iron.
I would avoid liver in that case, yeah. And or like if you want to eat liver, keep eating liver, but be really careful with the iron levels. Like Mercola is really good. Joseph Mercola, he's really good with iron. Like I actually tell people to go to his website specifically and read about iron, because it's like vitamin D. Like there's a difference between being quote unquote normal and then being optimal with your iron.
Yes. With vitamin D, we got to take a side detour for 2 seconds on vitamin D, because we talked with Master John about this a lot. But did you watch Ivor Cummins' presentation, D is for Debacle? Have you ever heard of that? Oh man, it's amazing. He spent like a year putting this together, and it's amazing about vitamin D, and that everyone is just basically deficient in it, and how important 100%. It is. Yeah, and when you get those levels up, it's so helpful. and that it's connected to so many different diseases. And
there's so many people with genetic issues. I would say like 90% of people have a genetic issue in some aspect of their vitamin D receptor or their production in their liver or whatever, or their skin conversion, like all the different aspects. When you combine them, probably 90% of people have a genetic issue, which means they need more D.
Yeah. Well, he thinks you can get too much and that it's bad.
Oh, for sure. Well, you can. I mean, there's no question. The thing is like,
how many people are getting too much though? Is my kind of point.
Nobody. Almost. Well, and then if you come in and you get like a 70 on your blood test, the doctors will tell you that it's too much. But what's funny, they did a study. Like, I don't know what I've come and said exactly, and I like him, but Michael Hollick is the guy to go to, because he's from Boston University Med School, where I went to got my PhD, and he got fired from Boston University because he was talking about vitamin D and saying basically the medical system is way off base and the numbers are way too low. Yeah. And they fired him, and then he sued and they got hired back. Like, they had to hire him back, which is how awkward is that, right? Like, like every day going to work knowing like you got fired and now you're forced the university to bring you back. But he's a cool guy. I love him. I went to like talk to him and stuff, and when I was there, and he's the guy, kind of the pioneer of optimal ranges for vitamin D, Michael Hollick.
Okay. What is his like 25 OHD recommendation level?
That's like, I don't know exactly, but I have a pretty good idea. So let me just see if I can pull it up on Google. Michael.
Well, just know, okay, I'll try to kill time here, but I feel like it's like a lot of people are under 20. And you're talking about 70.
No question.
Yeah, 70 is probably too high, but I think Ivor was like,
here's why I think it's not, right? Well, tell me what Ivor said first.
Well,
I'll tell you why.
No, he's like definitely get it above 30. He's like 30 to 50 range is great, it seems.
Yeah. I mean, it's complicated. He's got like paragraphs written, right? I can't just see like a little picture chart from him. But like I say, I kind of have a sense because I've talked to him about this, and I have the data. Like, I've looked up the studies. So they've done studies on hunter-gathering tribes. Yeah. That's the key. Right? Like, that's what you need to go to. It's like those people aren't supplementing anything. They have a six-pack. They don't have any artery issues. Their brains are like functioning hot.
They represent our ancestors and what we should be getting. Yes.
And we've done those studies. And of course, they use like European units or nanomoles or whatever instead of nanograms. So it's tricky, because if your average reader would just jump on PubMed and look them up, they get confused pretty quickly. And you have to have access to the full studies. But I've looked at them. I have the data. And the average person in those tribes is 70.
So 70.
And a lot of the pregnant women were at over 100. They were up to about 120. No supplements. Right?
Well, just to be clear, Ivor wasn't saying 70 is too much. He thought there was like no upper limit. I mean, he didn't really talk about upper limit, and he was promoting.
It's definitely, you can definitely get, I mean, like, I don't like to see people, if you get over 100, I get nervous.
Yeah.
Like, you can get calcium in your arteries from that.
Yeah, calcium. It's involved in that pathway, and you can get kidney stones too, or something, right? With the calcium.
Yeah, you could have. I mean, there's potentially a lot of. I don't know, like all that. I know for sure the calcium in the arteries, that would be the most concerning to me. And kidney stones is a little more genetic. Like, some people are more at risk for that. Some people aren't. But everybody would get calcium in their arteries if they started way overdosing. But it takes a lot. Like, it'll take like 20,000 IUs to start getting up there for most people. But again, that's where you got to look at the genetics, right? Because the genetics tell you a lot about how much you should take.
Well, if you have, they all work in concert with each other. If you have
you need the K,
and K, and the calcium and all this stuff goes together.
Right, exactly. But at least in my mind, like, the average American is 30, the average hunter-gatherer is 70. Yeah, that's where we start with the conversation. And
mine was like even less than 30, but
it probably is now, but. Yeah, I mean, most people that I see that are about 30, but they take multivitamins with like 400.
Yeah, you're probably seeing the like good people that come to you.
No. I mean, I'm talking like the Mayo Clinic or whatever. Okay. Not people for my DNA consulting who are interested in optimizing. But I use 50 as a cutoff. Like, I want to see people above 50 because there's no. Like, you start to see issues when you start dropping below 50. They're pretty minor. They take a long time to come out. They're not super, like, you kind of have to tease it out. You can argue about it. You know what I mean? Like, if you think it's optimal to be a 35 or 40 or 45, that's cool. Like, go ahead. But like I say, the hunter-gatherers at 70, and I think there's an argument to be made that when you get below 50, there's some suboptimal aspects.
There is. Well, you should.
So I think get above 50 to 100.
D is for debacle. Ivor Cohen's YouTube.
Yeah.
This is required viewing.
Yeah.
Anyone listening
Awesome.
and you, I'm serious. It's insane. And also, I'm about to go out in the sun and read. That's my, as soon as we get off of this podcast, I'm going to head to the sun, and I do like, I put a timer. I do about like 18 minutes per side, and then I come in.
Right. Well, it's funny about Michael Hollick, right? He does consulting for zoos.
Mm-hmm.
And you know how like oftentimes you'll hear the panda bears are infertile at this zoo or whatever, and they kind of blame it on captivity. They're like, it's because of captivity, right? That's what people say. What's super funny is he gets paid all this money to go around the country, and he basically goes in and like he's done with the Komodo dragons and all this. He's got all these cool stories. And he basically just gives them vitamin D, and instantly they're fertile and they're all like healthy again. That's the only thing, because they're not getting vitamin D through the glass.
Oh, yeah.
Even though they just have, like a panda bear, they need the sunshine on their nose, just that little bit of skin in their ears. That gets them enough vitamin D to at least survive. Yeah. And of course, their receptors are super sensitive to it and all this kind of stuff. But they need it. Like you can't put them in glass and then expect them to thrive. Yeah. So super funny that he just goes around and just injects animals with vitamin D and gets paid like serious dollars for that. He's kind of like a one, how like if you've got a hammer, everything's a nail sort of thing, is one of those.
Yeah.
But it works for him.
Cool. Good for him.
He was the pioneer of the suboptimal versus optimal versus normal range, which is government recommendation range. I think iodine is similar, like the iodine optimization. So many people have iodine related genes. It's just so common. It's like if you're telling everybody to take iodine, you're probably on the right track.
Yeah. So that's in iodized salts. Everyone knows that that's like the normal table salt, but then we're talking about using like Redmond salt, Himalayan salt. So where else can you get iodine? I mean, it's in seaweed. It's in the seafood.
Yeah. But nowadays it's so risky to eat seafood all the time because of the mercury and everything. I would just take it as a dropper. Like I just get a dropper and put a drop in my water every day.
Yeah, I like those kind of hacks. Like, I think you talk about magnesium as well. I just saw this study that it's been depleted like 80 to 90% in our soil and food. Right? Yeah, since 1900 or something. And it's insane. It's like you can get a sack of magnesium on Amazon
for nothing. Yeah,
right. I mean, it's like I have bone broth all the time. So I'm like, after my meal, I'll drink some bone broth and I'll just scoop a little magnesium in. I'll put in a little potassium too. It's like, why not shake a little potassium in there? It tastes salty. A little Redmond salt, a little potassium, and I'm set. It's like these are just these electrolytes that everyone should be having. And I don't even consider it supplementing it really. Like I also don't care if I need to supplement, because it's our modern environment that has the problem with the magnesium, not that my diet is bad. Like I have a very good diet, but
and if you have your own garden and you're putting actual, animal manure and all this kind of stuff on your garden, and you've got healthy organic matter and all this, no big deal, right? It's just the problem is the way our modern farming is done. It's just, and I did a YouTube video on this, like one of my first ever YouTube videos out of like the 100 that I've done. It was on the soil depletion, because I think it's such a big problem. And of course, YouTube has probably kind of hidden that video. It's hard to find, I think. But it's on there. Like you find like I did a video on fluoride as well. And you can type in like my exact name and the title of my video and it won't even come up, you know?
That's a little
Whereas most of my videos come up just fine. I've had hundreds of thousands of views.
Yeah, it could just because it's old. You can also make your playlist.
Sure. Yeah.
You can change the order. I figured it out finally. It's not easy on YouTube to like change your collections.
I'll probably just redo the video now because there's some updated info on fluoride I want to get in, but I'm not a huge fan of fluoride in the water. I'm actually an anti-fan of it, but the stuff on soil depletion, what they're doing is they're just putting fertilizer like nitrogen and phosphorus on the soil, and then the plants are pulling that up. They're also pulling all the micronutrients, the minerals out of the soil, and those aren't getting replenished back in. So just year after year, they're just putting nitrogen back in, and then they're just putting nitrogen the next year and nitrogen the next year and just keeping the plants growing, but they're not really drawing up any more of the micronutrients because they're all getting pulled out. That's why it's so darn depleted. So it's only getting worse,
Yeah, that's a huge issue. And I've had a lot of environmental, sustainable farmer type people on the podcast as well. And just growing the plants and animals together is huge. It's so maddening, these people talking about how bad meat is for the environment. And that's like, you guys are so off. It's like, okay, where are we getting these?
Well, it is if you're feeding them soy and corn.
Well, yes, we should get into that stuff too. But it's like, where are you getting these fertilizers from if you're not getting from animals? It's like these fossil fuel based fertilizers too.
Yeah, it's crazy. I mean, it's frustrating because oftentimes with the soy, especially, and I go through this in my book. It's funny, I have a whole chapter in my book about the bias and the corporate influence and all this stuff. And I thought the editors were going to pull it. I had like 10 editors, and I thought they were going to like say, oh, this isn't really about artificial estrogen. It's about corporate influence. But actually, almost all of them said it was their favorite chapter because they didn't realize behind the scenes what it was like. Wow. Because I publish peer-reviewed science papers and things. I just published one last week, in like an orthopedic journal.
Oh, cool.
And I've just submitted another one like in a week or two I'm going to. But these are like technical. They're not something I'd recommend your audience run out and read. They're boring. It contributes a little bit to something specific that I work on or whatever. But, it's like there's a lot of opportunity there for corporate manipulation with the way our system is set up in America, and they take advantage all the time. You can talk to these guys. Like I've talked to CEOs of huge biotech companies and everything, and they don't even trust the science. Like they say 70% of this published science is total BS. 70%, like they don't even trust it. So when they have like even the drug companies, if they're going to develop a new drug, if they find a scientific publication that says, we discovered a new drug, it's amazing, here's what it is, they repeat all the studies in that published paper, and most of the time they can't replicate them.
Absolutely. There's so much going on with the drug companies, and they can do 10 studies and then wait till the one that works and then try to put it out. Well, then even more, as I listened to some podcasts, it might have been on NPR, something years and years ago, just in general, they just can't replicate like 80% of studies.
That's exactly what the CEOs talk about.
Just like in general, like all studies, like any study, not just,
Yeah, because it like depends on the temperature, the pH is a little off, or like some little tiny variables off, and the whole thing breaks down. It doesn't even work outside of this like really artificial contrived system.
Yeah.
So that's why you need like a lot of validation from a lot of different sources. And you have that with these artificial estrogen studies I'm talking about. It's like, they've done a million studies on BPA, like almost literally, maybe literally a million, like certainly tens of thousands. So it's not like there's just one study showing some of these problems. And you can find like the one study that shows there's no problems. You'll find 10,000 that show that it acts like estrogen. Then you find one that shows that it doesn't act like estrogen, some specific contrived artificial whatever system. And then everybody cites that one.
Of course.
Not everybody, but there's a few people out there, of course. You always find those people.
Okay, so we talked about so many things. I want to make sure we finish everything off. The iron thing, are we good with the iron?
I think so, yeah. Well, I mean, most people, they do pretty well with iron. I think there's an optimal range, and then most people are higher than they should be.
Okay.
So like I think the medical, like there's different ways it's complicated, right? Like there's different ways to measure iron, like transferrin and transferritin and ferritin and iron and all this. And that's why I always push people to Mercola, because he's really good on it.
So just something to check for if you're going to get some blood tests from your doctor. Just look at it. Look at your vitamin D levels. Make sure they're very high.
Right. Make sure they're optimized.
What else? What else are we looking for?
Well, it depends on the genetics, right? I mean, like there's no sense doing all these extra tests if you don't have the genetic issues for them. It's very predictive. Like people are always astonished at how I can predict what their blood levels of things are or what there might be high. Like some people have a gene for CRP, high C-reactive protein, right? And they're like, oh yeah, I struggle with CRP all the time, right? Like they didn't realize like it's actually a genetic thing, and then there's specific things you can do. Right.
What's an example though of what they can do? Like eat low carb or low sugar, low processed foods, or
there's like a dozen ways you can lower CRP.
Yeah.
I mean, I don't even have off the top of my head all of them, but I have like lists and stuff that I would have to go to.
Well, it's fine.
No, well, what I would do is usually for that specific one where it's something where there's like 10 things to lower CRP, I would probably point them to Self-Hacked, the website Self-Hacked, and say, here's a link.
Good site.
I'm a scientific advisor for that.
Okay.
That website, and I love it. It's really good. It's easy to read.
Yeah. Cite all the sources and everything.
Exactly. They got the sources, so then they're not just making stuff up like WebMD or something. No sources, and then they also are practical. They tell you what to do, right? Like vitamin E drops CRP, for example. Vitamin D does too, by the way. Niacin, folate, there's so many things. Selenium, magnesium, DHA usually drops, CRP.
Okay. Small tangent here. Talking about all this nutrition stuff. Do you have strong nutrition views? Like, I'm trying to make like this ultimate framework. I'm not trying to say there's one diet for everyone, but kind of put together this sapien framework, right? This is just what humans should eat, and this is how. Do you have some ideas on that, like an array of foods or like a style of diet, or just some of this top level stuff that kind of affects people the most? Like, what are the big things they can do?
Yeah, I mean, it's super variable. I think for sure iodine and vitamin D, like sunshine, right? I think we must have originated either next to the ocean or somewhere real close to the body's water. There's so many connections between DHA and
we kind of migrated
iodine.
Like next to rivers and oceans, right? As we moved.
For sure.
But of course, people were landlocked, right? There was lots of cultures that didn't. But
right. For me, it's all about the DNA. I figure like, let's use the technology and look and see what your specific thing is.
So you can't.
But there's definitely
recommendation.
You kind of can, but it has to be broad, right? Like I think there's definitely fundamentals that apply to everybody, and I think that's where the DNA helps too, because it helps you recognize like, oh, this doesn't apply to everybody, but this does, right?
So what are the good ones for them?
Well, I mean, I haven't given that much thought. Like I think teaching your body to burn fat, for example, is fundamental. Like there's no gene. Like Rhonda Patrick would probably argue with me on this because she thinks there's people that don't do well with the keto diet and all this. But I think everybody should be able to cycle into ketosis and out of ketosis, and that should be super good for everybody. Yeah, it doesn't matter what your genetics are.
Seems likely that if throughout history, if we're around, it's because we were good at burning fat, right? Everyone, no matter where they're from.
And I don't think everybody's optimized to just be in ketosis all the time, obviously. Exactly. And some people do try and some people think that, but I think for sure you should be able to cycle in and out of ketosis. There's no question.
Well, you said teach your body. This is what I'm a fan of. I'm definitely not always in ketosis or promote that. I'm a huge fan of getting fat adapted, and then you go from there. And at least you have that metabolic flexibility. Most people don't have that metabolic flexibility at all. Yeah. Right. So at least like get there, spend a month maybe, and then see what works for you and go. Yeah,
I think intermittent fasting is another fundamental. Like absolutely 100%. Everybody should do it.
100%.
It's just a fundamental thing. The way your body works, it's optimal to intermittent fast.
We shouldn't even call it intermittent fasting, right? It's just like
be normal.
This is normal. Just don't eat all the time. Just eat.
Or fighting against this corporate culture that's told us that breakfast is the most important meal of the day. That's the bullshit you have to fight.
Yeah.
Everybody thinks that if you get outside of the health circles.
Yeah.
And so that's the battle there, is to say that's actually completely opposes your natural physiology, which is crazy to say. Like we've all been educated in the way that's opposite to our natural system. But there's no question to me. So iodine, sunshine, or seafood, sunshine, keto adaptation in and out of ketosis. Intermittent fasting all the time for the most part. I'm tempted to say lifting heavy, but it's not quite true. I would say 80 to 90% of people should lift heavy weights sometimes.
Well,
but it's not quite a universal in my mind with the genetics.
Well, yeah, I agree. So who wouldn't want to?
It's people that have all these endurance genes seem to benefit a lot more from doing endurance activity, especially there's different muscle structure related genes, and then there's also different brain related genes. Like some people have genes relating to schizophrenia risk or depression or whatever, and it seems like they do better with endurance.
Okay. Yeah, I shouldn't trash on cardio all the time. I kind of do.
It works for most people, right? Well, I think by far most people need to get away from the crazy cardio stuff and get into the heavy.
That's what I'm saying. It's just intense, and brief, intense exercise is just far more just beneficial, and it's time efficient. There's so many factors, and I always say, yeah, I mean, if you like to do cardio, do it. If that's your thing, absolutely. Of course, like do something rather than nothing, and don't,
Yeah. But I do think there are people that the heavy lifting isn't that beneficial, and they need to do high rep to get the burn and all this kind. Like it does seem to work just based on the genetics again.
Well, okay, so I talked to Keith Barr.
Pretty close to it.
I talked to Keith Barr about this a lot. And I'm not saying that you have to lift heavy, but at least you're doing resistance training, right? We were talking about going to failure. Like that's more important. And you can go to failure and do 30 reps, but just do it to failure. It's not about...
Sure.
Yeah, I mean, I'm not saying everyone needs to do like squats for like 300 pounds and do 5 reps.
Right.
It's like, I use dumbbells to do squats, right? And I can just, because that's all I have in my gym, and then I can go to failure and get a really good workout.
Yeah, so I think the fundamental principle for sure is everyone needs to spend a lot more time moving and exercising
Yeah.
and training, and exactly how to flesh that out is tricky. And it does matter. Like, I work with pro athletes, right? I've worked with MMA fighters, all kinds of interesting people. And it's sometimes kind of funny to me. Some of these guys, like these professional baseball pitchers or whatever, they're in the Major League Baseball, like MLB, right?
Mm-hmm.
And they've never developed a foundation of strength. Like they've never deadlifted or whatever. Like, I think everyone should develop some foundation of strength, which was what I call them the big 6 movements. So that's the deadlift, the squat, that's push pull with your legs, the bench and the row, which is a push pull with your arms, and then a vertical push pull, which is overhead press, and a pull down. Like, that's what I call the big 6. And I think everyone should develop like a foundation of strength with those, where you work up really, really slow on all of those moves to the point where you start to find where you plateau. And then that's where you get more advanced with like deloading weeks and changing up your cycling and all this kind of stuff. Like, but at least develop a foundation of strength.
And a lot of those you can do without equipment. A lot of people don't realize, like, you can find like a pull-up bar, and you can do push-ups, and you can squat with your body weight. I mean, there's lots of ways.
Right. But I think the key is, I think if everybody had a barbell, that's what you need.
Yeah.
You know, like, it is hard to row without a barbell. Like, the rowing is tricky, and it's so important in our culture because everybody's sitting all the time, so our shoulders get pulled way forward. Yeah. And it helps to row. Like, you can do a bent over row with the barbell. They call it a pendlay row, like pendlay, I think, pendlay. But anyways, you can do every single of those, all the big 6 movements, and develop foundation strength, just a barbell and the weights for the barbell. But
exactly, the squats and the deadlift. Yeah, that's huge. So yeah, we're not saying you need to be some pro lifter, just
develop a foundation of strength.
Okay, so what's more? I'm gonna throw in like not eating processed foods and sugar.
For sure, yeah, that's a gimme.
It's an easy one. Yeah,
nobody's built for either of those. That's what everybody says, right? Like, I've talked to people about this too, because I've thought about this myself. It's like, well, what is the foundation? Especially from my perspective, because I look at so much personalization, and I'm constantly saying there's no perfect diet for everybody. Like, you can't be a vegan and say that applies to everybody, and you can't be a carnivore and say that applies to everybody. You just can't. Like, you can't even do keto and say that applies to everybody, whatever. Because even different ages, there's probably differences there, right? And if you're a different sex, if you're different active or not active or whatever lifestyle, like pro athletes, you know. So I've definitely thought about this exact question. And that's usually the one I go with. I go with processed sugar or the processed food and the sugar, because everybody's like, oh yeah, that's a huge, it's such a gimme. Nobody disagrees.
Yeah, but
if
not
you start saying
like, though.
That's true. And yeah, even me.
It's hard.
But at least I know.
Yeah, no, it's super hard. So it's like, people need to focus on it. Just keep on hitting with it. Just tell them how important it is. And then, just try as hard as you can to avoid them.
Yeah. And then of course, sleep is a big one, like optimizing your sleep. So I think irrespective of your like, there's a bunch of genes and you can look at all this stuff. So like, some people respond better CBD with sleep, infrared with sleep, whatever. But I think everybody should stop eating like 4 hours before bedtime, or a certain amount before bedtime. So usually that's, for me, it's 4 hours. If I eat 4 hours in that window of time before I go to sleep, it totally screws up my deep sleep.
I do 4 hours as well. You know, the easiest way, I just say, I haven't said this much at all, just don't eat 4 hours before you go to sleep, and don't eat 4 hours when you wake up, and that's it. Yeah. I mean, that's basically just an 8-hour eating window. And like, I'm not hungry for 4 hours, you know, when I wake up. Right.
Yeah, you have to train your body. It takes a few weeks for some people.
And you have to be fat.
I agree.
It's better to be fat adapted too.
I've never eaten breakfast my whole life because I'm gluten sensitive. So like, I didn't realize that as a kid. I found that out when I was doing my PhD, and then it just snowballed into like, holy shit, what else have I been told that like that's bullshit? Because they always, people scoffed at that idea when I was doing my PhD, like the educators and stuff. It's like, oh, gluten free, that's silly. And this is like coming from the top down, right? But then I discovered there's no question I'm gluten sensitive. And I think when I was a kid, all my parents had was cereal. And I would eat that and get a stomach ache. So I just stopped eating breakfast as a little kid, and I never have. Like, my whole life. I've never eaten until 11 or 12 p.m. And so basically, I've always intermittent fasted, and that's how my body like functions optimally, without a doubt.
Yeah, it's just better if you get fat adapted too. It's easier when you're good at burning fat.
Yeah, so like that, like that's a fundamental, I think, for your book, right? If you're going to write a book on it or whatever you're going to do on it.
I'm kind of putting what's put together for the film for sure. I am writing a book alongside this because there's just so much information that I'm taking in. It's like, why would I not put it?
There's another the irony that I've discovered too with DNA consulting. Flavonoids are huge. Like there's so many people that need flavonoids.
So these are from plant things,
colorful plants, right?
Yeah. So
that there is some truth to the colorful
carnivores. Sorry, no, I'm like all over the place with. I've never been carnivore. But I have like Paul Saladino on and talked to.
I've been on his podcast.
Yeah. Yes, I've listened to that one. I help Paul with his podcast actually. So
nice. And where do you live?
I'm in Marina Del Rey. I'm in Venice Beach.
Oh yeah. So you're in California.
Yeah.
But
okay, sorry, to finish it off. Yeah, so I talked to all the carnivores, but then I talked to Chris Masterjohn. I feel like he hates me after this podcast.
Chris or Paul?
Chris. No, Chris. Because I was questioning him. I was like, hey, I had Saladino on. I want to hear all the counter arguments. And I felt like he was getting, I hope he didn't think that I was just trying to argue with him, or because Chris has all these ideas of why all the plant foods are healthy, and he listed all his reasons. So it was just like a kind of a weird.
I got to hear that. I want to hear that. Is that one out?
I'll put it out next Tuesday night. Yeah.
Okay, I'll definitely pay attention. It's probably come out before mine. Well, before mine, so that's good. Yeah, I'll listen. And the thing of it is, right? Like, there's some genes where people should absolutely not eat plant sterols. Mm-hmm. Like there are genetic people where they're optimized for the carnivore diet in terms of their genetics, but it's really rare. I mean, it's really and I'll give you the specific genes that you can look them up, right? One of them is called ABCG5. Okay. If you've got that gene, your body doesn't clear plant sterols. So plants make these things called sterols. They're like cholesterol, but they're the plant version of cholesterol. And for most people, they eat those and their body clears them right out. No big deal. But for some people with a gene issue on their ABCG5 gene or their ABCG8 gene, and that's less than 5% of people, by the way. That's less than 1% of people with the extreme form of it, but even like a partial form is less than 5. But 5% is still 90, you're going to find people. But they have huge risk for gallstones and things like that. And they also have risk for plaques in their arteries that are formed from plant sterols, right? Like the cholesterol gets so high in their body, the plant cholesterol, not their natural cholesterol, not the stuff you're making sex hormones from, but the plant sterols get so high in their blood, they get oxidized to become inflammatory. And the tricky thing is doctors don't check for plant cholesterols in your blood, right? So they'll miss them on the blood test. They won't realize that, oops, this person is loaded up with these plant sterols. And they're becoming, and it's the same problem with humans. Like if you've got a person that has a genetic mutation giving them something called familial hypercholesterolemia, then they get so much cholesterol in their blood. It's like off the charts, right? It's in the thousands, the total cholesterol. Then the cholesterol itself becomes oxidized and inflammatory. Like the cholesterol is not causing the plaques. It's still the inflammation. Like it's always the root cause is inflammation to me. People will argue with me on that, but I think the root cause of artery plaque is inflammation, whether that's from iron being oxidized and causing inflammation, whether that's shitty diet, whatever, gluten. There's different ways to get inflammation. But for people with familial hypercholesterolemia, which is kind of the classic argument to say cholesterol causes plaque, right? Because when your cholesterol gets sky high, you get tons of plaque. Well, that's because the cholesterol gets oxidized when it gets sky high because your body's not clearing it out, and then it gets inflammatory. It's the same with plant sterols. Like if you've got sky high plant sterols, they get oxidized and inflammatory. See what I mean? So for those people, 100% carnivore, absolutely. Like those are the people I say. Yeah. But the irony is that's 1%, right? But probably 95% of people, they have gene issues on their CDK genes. They have there's a molecule called CDK that can cause inflammation. And you want to inhibit CDK, right? And if you're not inhibiting CDK very well, you're getting inflammation. And you have these CDK genes, and they're CDK inhibitor genes, and most people have issues with those genes to some degree. And you need assistance from the flavonoids because flavonoids inhibit CDK. And so like almost everybody I come across, I'm like, yeah, you should make sure you get plenty of flavonoids because they inhibit CDK and you got CDK gene issues. Almost everybody.
Wow. So this kind of conflicts with Saladino's theory of
True.
Yeah, I mean,
But that's like strict carnivore, right? Like he's going super strict, and I don't think that's optimal for everybody. But
well,
I think eating
so.
meat, I agree with them on the eating meat part for sure.
Yeah.
But just eating meat, I did a study, like I did a crowdsourced study where I had tons of people interested, and I had 10 people sign up to only eat meat, to do carnivore. And I was very strict, like I would not let them cheat, right? They have to eat only meat, right?
Well, was
meat,
this
salt,
nose
and
to
water.
tail, or was this just like muscle meat?
It was nose to tail. If they read, and I sent them an email and they had all the info on it.
Yeah, so liver.
Every single one of them dropped out.
Okay.
Like one of them was puking in the middle of the night and all this kind of stuff. Like they all had all kinds of issues. And you could say it's because they're transitioning and all this, but still, like just from the perspective of sustainability, like people's actual adherence.
Yeah.
It's super hard. Now, it's not that hard to adhere if you're doing quote unquote carnivore and eating avocados here and there or whatever, like what most people do. Most people don't admit it, but that's what they're
cheese,
doing.
They'll eat all kinds of stuff.
Exactly. And they don't admit, they still say that they're extreme carnivores, right? On YouTube or whatever, on Twitter.
Well, okay, so
Saladino is, he's legit.
No, he's super legit. So he's
cheating.
come to my house and wouldn't eat anything in my house, even though the only thing he ate was my nose to tail. Nosetotail.org is my company. I sell grass finished meat.
Nice.
Yeah, delivery. It's like out of Texas, but that's the only thing he'd eat because it was grass finished, and I have the organ meats mixed into the ground beef. Nice. Yeah. So he ate that, but he wouldn't drink my water, which sounds like a good thing. We need to get into all these little details of how people can avoid estrogens and all this stuff before this gets to be a 2-hour podcast, which it is. But just interesting. So when he's very strict, very
well, I would like my main point of bringing it up is like flavonoids in my mind. Just again, going from a DNA based approach and saying, okay, what do I recommend? Pretty much everybody, flavonoids.
Okay.
Flavonoids, iodine, magnesium, like I say.
Yeah, flavonoid. So eat the rainbow there's a little something to it. This is Master John kind of talked about this too, and said that there are these polyphenols and things that actually. The thing about
polyphenols is a lot of them act like estrogen. Like I like to use grapeseed proanthocyanidins. That's my favorite. If you're just going to pick out one supplement, like so if I was a carnivore, I would still throw in the grapeseed proanthocyanidins because they're just pure flavonoids that inhibit CDK. And they don't have any estrogenic aspects.
Wow.
Whereas a lot of the polyphenols do have some estrogenic. They act like estrogen. That's Paul Saladino's argument. And that's a very valid argument. Like when you're purifying out the polyphenols, you're probably spiking your estrogen too high. Like it's an unnatural thing,
Well, there's a couple
playing
things
with
too.
fire.
With carnivore, I wanted to wrap up. Other than the plant sterol problems, I feel like so many people who do carnivore, they don't really do it by choice, and they do have good adherence because they're very into it and they have a lot of problems, and that they have a lot of gut problems, autoimmune problems. So it goes beyond just these genes you're talking about. It's that people have from the environment, from our food environment and all detox. They have major problems and they need to do it.
True. Yeah, they've developed. What happens is when you get a leaky gut, right? You got these food particles going into your blood, and then your immune system is attacking big chunks of food. And most of the plant compounds are very different than human cells and animal cells. So the immune system is more prone to attacking plant matter than it is to attacking meat, because meat is so similar to human. So that's absolutely an issue when you develop that leaky ass gut, which most people have these days. To try and recover from that, you've basically vaccinated yourself against all plant food by dumping plant matter into your bloodstream, and in that case, it's totally legit. Like I agree with you there for sure.
And then maybe you could add stuff back in later
and test it out, right?
Yeah. And then what are the safest plant foods? Because we didn't even talk about all the anti-nutrients. There's this estrogenic stuff in plants, but just the anti-nutrients, oxalates, and all this stuff people have problems with. So.
Yeah, and
if you're gonna eat the rainbow,
back to
what about lectins and
Yeah, no, I know, and that kind of goes back to like just a little bit of awareness, self-awareness, and tinkering, and some of the genetics you would have to look at to get real specific on that.
Do you have any recommendations, or you're not good that level of nutrition of like what are the safest plant foods, or how to mitigate the effects? Like I know, just say for peppers, so it's like you're talking about colorful red peppers, orange peppers, but then there's like lectins. It's like you can take the seeds out and you can.
Well, even crazier is the nightshades, right? Like so going back to Gen X, right? So what I always try and do is just go back to the genetics. So there's a gene, it's called BCHE, And if you've got that gene issue, you're sensitive to nightshades almost every time, right? Like you can't deal with the nightshades, and that's tobacco, that's tomatoes, that's the whole thing. So but that's not super common, right? Like, so I always go to the genetics first. And so some of that stuff is pretty customized, right?
Okay.
Like you can see how customized I get kind of in my thinking for all this stuff.
And how accurate do you think that genetic stuff is?
Super accurate. Like it's unbelievable. Like one of the reasons Dr. Gundry was so successful with the lectin stuff that he talked about is because a lot of people have genes in their brain that are related to lectin problems, and some people have diet related genes related with lectin, like leaky gut genes, for example, that are specifically lectin related genes. They're out there, but not everybody. Probably like 25% of people. So like 25% of people that read his book are like super fans because they find it's like a massive thing. But at the end of the day, it kind of is because their genetics fit what he's preaching. And that's why I like your approach in terms of saying, well, what applies to everybody, right? Because the lectin-free diet doesn't. Like, I don't think it applies to everybody. But if the people that does apply, it's super important and valuable information. And I've talked to him for like 2 hours, right? Like, I really appreciate that, what he's brought to the table, but I feel like you've got to add that genetic component to understand the whole picture on most of these things where we get down in the weeds.
Yeah. And for everyone, it's Plant Paradox's book. This is super interesting. I want to have like the ultimate book or ultimate something, whatever it is, or a film that kind of tells you all these things. It's like, okay, that's what I'm trying to do, really. I mean, I'm a mechanical engineer. I'm not a nutrition person. I came at this from an engineering standpoint. The
good thing is I've done the DNA consulting for so long. I have this giant, group of people that could jump on. Like, they'd probably be willing to say, yeah, I'll talk for 2 minutes and just say, like, I have this gene and this is the issue I've had and here's how I fix it, whatever. You just go on and on.
Yeah, we should team up. No, you have really interesting stuff going on and we could figure things out. It's like, look at it from this kind of non-dogmatic viewpoint.
Right.
It's like, I don't care about vegans. Yeah, like, I don't care about carnivore. I don't care about vegan. Like, I'm just here to figure out nutrition. Yeah. And then we can make the ultimate blueprint of like, this is the big pillars that work for everyone. This is the DNA testing you can do. This is, even like carb testing, like Rob Wolf. It's like, do your carb testing, right? Like,
love it.
Figure it out.
Well, and some people have genes, like you said, it always goes back. Like, some people have insulin resistance from their melatonin receptor,
Oh, really?
And it's a lot less related to carbs and it's more related to melatonin. There's people where their brain doesn't do well with carbs, and that gives them a higher risk for Alzheimer's. And totally different risk than the DHA ones we talked about before. You know what I mean? Like,
maybe we can really figure this out. Has anyone put this all together? I mean, you're putting it together with your consulting, but maybe we should really, team up on something.
Yeah, we should. I'd love to do a video because I'm working on books on these topics. That's why I've thought through them so much, because I've been doing it actively since 2010. And I've developed such a repertoire of different categories of ways to optimize and thoughts on this. And so the problem is I work full-time at Mayo Clinic, which means I don't have a lot of time to write books. And that's what's been the difficulty. It's like, oh man, I got to get these books out there, right? But if we had a video as well, more people would be into it.
All the things. And are you writing a testosterone book?
I've been working on one. Yeah.
So, okay, we need to get going here. But what are the high-level stuff on testosterone?
Oh man. Well, I think the biggest mistake I see in the testosterone optimization space, and I work with a ton of guys, is because I do some stuff with Jay Campbell, and he's got a huge audience of people that are testosterone optimizers. The biggest mistake I see is people don't test their heavy metals, and so a lot of people have a lot of heavy metal exposures, and that drops your testosterone. Even a lot of the micronutrients, like if you've got too much nickel, if you've got too much copper, a lot of these essential micronutrients will drop your testosterone if you have too much of them. So people that are taking 100% of their daily value of all these things in a multivitamin, and then they're eating food on top of that, which of course they are, they're getting way over 100% daily value. They're probably dropping their testosterone in a lot of ways, but they're not checking for their heavy metals. And then when they do, they realize, oh, my heavy metals are high, but then so they're dropping their testosterone with heavy metals. And then they say, oh, my testosterone's low, so let's start injecting it. And then they bring their testosterone up, but that doesn't fix the heavy metal problem, right?
It's always root cause. You got to look at the root cause. Yeah.
And so then the heavy metals cause all kinds of other problems that were never addressed. And so it's always a simmering issue. That's the biggest one I see with the testosterone optimization space.
Okay.
There's other ones. There's a dozen other ones, right? But that's the big one, I think.
And limit your estrogen. So, okay, so let's get
I mean,
to
I
the
guess
list.
that's assumed. Yeah.
Well, maybe we should finish off the top 10 estrogen.
Yeah, sure. Well, BPA, like plastics, I think in general, you want to minimize. Like you're always going to have some here and there, but don't store your liquids in plastics. Do the best you can. BPA and phthalates are both a problem. And it's not just BPA, it's BPS, BPAF, BPF. There's all these other ones. They act just as estrogenic as BPA, even though it's BPA free.
Yeah.
So get rid of the plastic. The other big one is the personal care products with the phthalates and the parabens, the fragrances, anything with the term fragrance on your label where they don't actually tell you what's in the ingredients is usually questionable. It's usually got estrogen chemicals hidden in there, petroleum products. Cautious with the fragrances. And I have a page on my consulting. It's ajconsultingcompany.com and then /what I use. I have a what I use page. I don't have any endorsements. I just tell people, hey, here's what I use. You can do that if you want, or you can find something else. But
you know what? You know what I found? Yeah, definitely go there. But I've just stopped using anything really.
Yeah, that's a good option.
I'm just like, wait, like all you need is hot water. You take a shower, you like get a good rinse going.
Well, like for shaving, it's like I shave my head every morning in the shower, so like I need something to suds up on that. Like I know what you mean. Yeah.
But yeah, no, it's crazy. It's like, all this talk about microbiome and stuff with your gut. It's like, well, there's like a microbiome on your skin. Yeah, exactly. Like you don't want to strip it off. It's like I feel like I've gotten like better personal hygiene by not using products because I'm keeping it all intact.
Yeah, I see that a lot with people. It takes a few weeks for your deodorant and stuff to kind of get out of your system and your body to kind of adjust, stop making so much sweat and stuff like that. Just in those areas, but I agree. But yeah, back to the top 10 list or whatever. I mean, soy and flax I mentioned. Smoking cannabis increases estrogen. Most people don't realize that. The edibles don't, but the smoke does.
I've heard that. Yeah,
especially if you're a teenager or something, you want to be really careful because a lot of infertility and stuff is going to come. Depression you might have can come from that estrogen.
Is it the smoke, or what about these new vape pens or whatever?
No, just lighting it physically. Okay. I don't think the vape is an issue. There hasn't been like a direct study, but that's just my impression because I've seen the studies on THC and stuff, and they don't have any estrogen.
Well, young
impacts.
People shouldn't smoke weed anyway. It's just
exactly. You're risking schizophrenia. But probably even up to 25.
Yeah, let your brain develop first.
Yeah, and then lavender essential oil kind of makes the plant list. So soy, flax, lavender essential oil, and cannabis smoking. Those are the big four in that category. There's of course the sunscreens. Like make sure you just get zinc sunscreen, and every other ingredient you can actually pronounce. I just use sun shirts. Because I'm super white. I go fishing all day on the ocean. I use sun shirts. I use the sun gloves. I use a sun hat. Like I go crazy.
Yeah, that's the best way to block it. And this is another thing. Just we got totally wrong, and that Ivor Cummins brings up in the video. Just why are you putting? And also Pete Evans. I like Pete. He came on the podcast a while back. Australian guy. He's like, don't wear sun. Like, why are you lathering on all these chemicals that are? And people are getting more skin cancer by being too blocked from the sun.
Yep.
You need some healthy sunlight exposure. Don't get burned, obviously, but like, don't slather all this stuff on yourself.
Yep. Yeah, mold is another one that makes my top 10 list. Like mold secretes, it's called mycoestrogen, mold estrogen. So that's a mold toxin that acts like estrogen in your body. That's why it's so bad, when they do these remediations and things.
And where did that?
So a lot of the grains in America have a ton of mold estrogen in them.
Okay. Well, speaking
so
of,
really,
we got
really not a fan of grains. Yeah.
Absolutely, don't eat them yourself. But we have to hit this kind of animal agriculture stuff with.
Yeah, good point. Well, the atrazine is the biggest one that I've seen. You do see mold estrogen in the dairy and all this stuff, just because if they're eating moldy grains and stuff, that ends up in there.
So how big a problem is it? Because I just told you I have a grass-finished meat company, so I'm really into that. But I'm also interested in letting people get what they can afford and not making everyone crazy, because it's like, hey, it's healthy to eat meat, and it's like if you can't afford it, don't just go eat pasta because you heard that there was like a little bit of stuff in the meat. So
the atrazine is the biggest one. Like the molds, you can find the references in my book and stuff. Like there's like 17,000 nanograms and all this in the dairy products or whatever. Dairy is usually the big one. The meats, I don't think, are a big one with the mycoestrogen, but you do find in the meat, you find the atrazine. That's the big one. If you've got grains sprayed with atrazine and then you're feeding it to the cows, they've done blood testing, and feedlot cows, like conventional standard feedlot cows, had 700,000 nanograms per liter of atrazine in their blood.
Their blood. But what about how much? So I know it's stored in their fat too, but how much makes it into the what you eat?
No idea. That beyond the blood, I don't know.
Okay.
Yeah.
So it's just likely bad, but
they showed it was in. Yeah, exactly. And they have done the fat tissue studies, right? Yeah. So I think that's one of the risks with eating a lot of fat from conventional, like bacon and stuff. Mm-hmm. Is you probably are getting a lot of those chemicals. I think that's also screwing up all the animal studies when they're doing these mouse studies or whatever, and they're feeding them all this lard or whatever.
Yeah.
They've got a lot of these chemicals in the fats, and then they're storing the seed oils in the plastics and all that. So there's plastic chemicals, and it throws a lot of the research off. It just makes it more confusing, you know?
Yeah, that makes sense. Okay, one more thing here. Saladino mentioned it on the podcast with you. He talked about eating cod liver in oil in a tin. That was at my house. Yeah. It's funny that he brought it up with you.
Yeah.
And I eat that. And there's also sardines. There's also smoked oysters in olive oil. Like obviously I wouldn't eat them in the other gross oils. But still, like I'll eat those because it's so much handier. It's so much cheaper. Like if I'm not like chugging the olive oil in the smoked oysters tin, like how bad? Like is it that much of a problem to eat some smoked oysters in a tin?
Well, yeah, I've tried to have it tested because most of those are phthalates. Like most of those are BPA free. They're lined with phthalate plastics, including the soda cans, by the way. The aluminum soda cans are also lined with phthalate plastics.
So even like LaCroix or like sparkling water, right?
Yeah, even the BPA free ones, all of them. Yeah.
Paul would only drink out of the glass bottle.
Yeah, I mean, and what's funny is I'm the estrogen guy, right? That's what people call me sometimes.
Yeah.
And I drink out of those. Like if I'm traveling, I'll grab a plastic bottle, right? Like
like have a LaCroix once in a while. It's like.
Well, I don't, but I make my own CO2. I have one of those CO2 injecting things. So I make my own sparkling water because I'm kind of addicted to it. So I can't help it. I do essential oils, and then I do some tangerine oil or something with a little stevia. Yeah. So it's amazing, and there's no estrogen. And my kids like it. They call it pop, like we're from Minnesota.
No, that sounds good.
It's basically like essential oil water that's bubbly. And that's their version of pop. That's what they think of it. But, and I have 4 kids, so it's, like I said, I don't like if you're going to do it once in a while, do it once in a while. Don't feel guilty. It's just the everyday stuff. It's when people are going to work every day with a couple of LaCroix, every single day. Well, it's just another
all
thing.
These things, right? Yeah, all the things you listed. It's like do the best you can or get the most of them out, but you don't have to be like an insane maniac.
Yeah, and that's me, right? Like, I mean, you're kind of saying Paul's an insane maniac.
I kind of am, but I love him. I love him, and I respect him, and I want him to be really focused on this stuff. Like.
Just had to point that out.
No, it's good. It's good that someone's doing it.
Yeah, right? It is a good example. Well, it does take a lot of discipline, and I have to appreciate that. I love that.
Yeah.
Because from that end, we need more of that in our culture.
Yeah.
But even myself, as the quote unquote estrogen guy, which I hate when people say that, I'd rather that they call me the anti-estrogen guy or something. Guy. No. That's why I need a book out there.
Yeah.
But yeah, exactly. Like even I'll drink out of a plastic bottle, and then people are scandalized, but who cares, right? It's like, it's not a good example, so I don't like to do it from that perspective, but I'll do it anyways if I'm traveling.
So do the best you can.
Yeah.
Get the most out. There's even more. Okay, keep going. It's like in the carpets. It's like.
Yeah, but those ones, again, that's where you're like, if you've got a breast cancer gene or a risk of prostate cancer from estrogen or whatever, then I kind of take it to the next level. Because, like a lot of the plastics are made from, carpet is made from plastics, things like that. Like the vinyl shower curtains are really bad for off-gassing. Like they've even done studies on baby mattresses, and they've shown that they're way above like the toxicity levels, which is bad. So like if you've got a plastic, like a vinyl baby mattress, get that thing in the trash, and get one that's phthalate free, BPA free.
Don't use Tupperware. Like, I've switched to glass a long time ago. All glass. Good. I use like mason jars, everything. I put my bone broth, obviously, especially when it's hot,
liquids,
right?
Liquids and hot.
Yeah. You don't want to put a hot bunch of stew you made in a plastic Tupperware.
Right. Yeah. Not even close. Yeah, I wouldn't even room temp makes me nervous, knowing what I know about the levels that leach. Yeah.
What about, and obviously not sous vide. Sous vide in plastic is terrible, but what if you use the silicone bags?
Silicone's good. Yeah.
Okay, good.
It's amazing.
I got silicone bags a couple of years ago.
Yeah, me too. I use them. Yeah, because I bought them and I use them because I did a research to make sure, and they're great. You can cook with them. It's crazy. Just don't get the dyed one. Like some people get these blue dyed ones, right? It's like, well, what the hell? Like if you're gonna get them, nobody's ever done a study on the blue dye and how much is coming out or whatever. But just get the clear ones. Don't get the pink ones or the yellow ones or the blue ones.
Yeah.
Yep. If you're gonna cook with them.
Yeah. I just made a page of recommendations where I actually put the sous vide bags and the magnesium I was talking about. So it's sapien.org/rex. Nice. Sapien.org/rex. I should put your DNA consulting on there too as some more recommendations.
Yeah. Just recommended general people do DNA. I mean,
that's kind of what you do, right? The what I use type of thing. Yeah, just
exactly. I mean, the reason I have that what I use page is so many people email me and say, well, what water filter do you use, or what is this, or what is that? It's like, well, I'll just show you what I'm not going to investigate every brand in existence.
Yeah, just
not happening. Yeah, I'll tell you what I'm using. So I don't want to leave anybody out. I don't want to like exclude people. It's like, oh, this one didn't make my list. It's like, well, I just can't keep up on that.
All right. So, okay, we're ending up here. So what else? Did we hit them all?
I think so. Yeah. And ultimately people should get the book. There's a lot there.
Absolutely. Estrogeneration.
Learn. Yeah, it's pretty easy to read, and it's the Bible of artificial estrogens. Like you're gonna get the idea once you get through it. And epigenetics is super important, so you want to understand that. Put simply,
Awesome. All right, I guess that's all. I had a list of things. I think we hit everything almost. Just water filtration. Okay, I use my fridge water. How bad is that?
It depends. I mean, I don't know which filter you have and stuff, but what I do is I have a reverse osmosis with a pump in it, so it doesn't have a tank. Like it doesn't have a plastic storage tank under your sink, which most of them do. I would say 99% of them do. I got the special one. You can buy it for $500. It's called Purify Guru. And again, it's just the one I use, but it's stainless steel, and it's got activated charcoal, and it's got a reverse osmosis. And I tried, so that's the only problem with it is a plastic tube going up to the thing, right? Just like your fridge thing does. And I tried to I actually got a silicone tube and replaced the plastic tube, but it blew up like a balloon.
Oh, wow.
Like when the water started going through it, and they blow those little kid balloons up that you make a poodle out of or whatever. You do all the twisting. It was like that. It like started to blow up, and I'm like, oh boy, like it's not rigid enough to handle it. So I have a little plastic tube it goes through, but it's phenomenal. Like I do like that. I think your fridge one is fine as long as there's no mold growing on the lines, like the tubes and stuff.
Okay.
Which a lot of people have when you take them apart. It's like, oh my gosh, there's mold all up in there.
Well, I just had them replace it. I live in an apartment complex, so they just replaced it. So
as long as they're doing that, yeah.
All right, so I love this. So it's this stuff that people don't really think about. From the outside, it seems a little wacky to get into all this estrogen stuff, but it's like really real. There's studies.
Yeah.
Do the best you can. What's your closing words? Just do the big things.
Optimized. Yeah, get optimized instead of don't follow the herd. Because there's no question. Knowledge is power. And if you don't know yourself, like Socrates says, know thyself, right? And that's one of my favorite things one of my favorite quotes, know thyself. And part of knowing thyself is knowing your DNA, because even with the estrogen, some people do a great job of clearing them. Some people do a terrible job. You got to know yourself ultimately.
Awesome. So ajconsultingcompany.com, get to know yourself a little better with a DNA consultation. And I'm going to put a ton of links in these show notes. Thank you so much.
Yeah. Thanks, Brian.
All right. Awesome. All right. We did it. 2 hours. If you're still around. Get your own grass-finished meat at nosetotale.org. Support the show on Patreon at patreon.com/peakhuman. Pre-order the Food Lies film at foodlies.org. Watch highlight from the film on the Food Lies YouTube. Get daily content on the Food Lies Instagram, Twitter, and Facebook. Sign up for the newsletter on sapien.org. Get on the waiting list if you're a health coach, doctor, or other healthcare practitioner at sapien.org. And stop listening to me because I just listed like 20 things. So just go to sapien.org and find all these links and stay happy and healthy, my friends.